everybody. How are you guys? Good evening, good evening, good evening. Am I audible, visible, everything is perfect? Please let me know. Sorry. The excitement because கொஞ்சம் டைம் முன்னாடி வரைக்கும் I was felt like okay எப்படியாவது இந்த கிளாஸ் வந்து முடிச்சே ஆகணும். I didn't have much energy also. ஆனா வந்து உங்களோட மெசேजेस அந்த chat வந்து பார்க்கல. அந்த names மட்டும் I was just randomly going through it. So அதிலிருந்தே எனர்ஜி கிடைச்சது. Like for like if I'm saying in the 5 minutes முன்னாடி I was just being like no energy, avlo dull irukke. Ana vande right now I am so happy, I am so excited. Enge irundha I don't know, by seeing your names itself making me more and more energetic. Okay, yes, I can see Arun Prasad, Navya, then Damodara, Lakshmi. Yes, ellarume ready ada? Audio video everything perfect ah? Please let me know. Audio video ellame vandu perfect ada? In the pen. Yes. Good evening. Yes, Kashifa, right? Yes, Jayashree, Christina. Yes, physics screen is back with lots of energy that is given by you people. Perfect. Okay. So இன்னைக்கு வந்து we are going to health வந்து better இருக்கேன்டா. Like அந்த லாஸ்ட் டைம் எப்படி இருந்துருச்சோ அதோட பெட்டரா இருக்கு. பட் அகைன் ரிகவரி ஸ்டேஜ் தான், பரவாயில்ல. தேங்க்யூ ஃபார் ஆஸ்கிங் டா, தேங்க்யூ ஃபார் ஆஸ்கிங். எஸ் சஜு. எஸ் லக்ஷ்மி, ஐம் குட். நோ இஷ்யூஸ் ரைட் நோ, மேனேஜபிள் தான். அன்னைக்கு வந்து அவ்வளோ, but right now it's okay. So இன்னைக்கு வந்து we are going to finish some of the chapters. Okay. Ramu, I just wanted to tell you, இது வந்து அவ்வளோ டீட்டெயிலாக இருக்கிற செஷன்ஸ் ஆகாது. ஆனால் we will cover each and every important points. Okay, so derivations எதுவும் இருக்காது. But again, excluding all those things, it is a detailed session. Okay, so இதில் வந்து first we will be having a quick revision இருக்கும். அதில் வந்து as I mentioned, point by point, each and every point வந்து we will discuss. அதுக்கப்புறம் we will be going for the question practice. So இன்னைக்கு வந்து what I have planned is electrostatics இருக்கும், capacitance இருக்கும், as well as gravitation. So இதில் வந்து அந்த first two chapters, in the electrostatics இல்லையாடா, so that is what we are going to study basically. So the rest gravitation வந்து இந்த chapter compare பண்ணி we will just finish it. Okay, அதுக்காக we are not going to put much effort, extra effort, additional effort எதுவும் இல்லை. We will just stick with one chapter. அந்த chapterல இருந்து we will finish gravitation. Okay வாடா? So in this session, if you are attending, and also they will be providing some questions also. So on the question practice, PYQ practice along with this session, I can tell you in the 3 chapters mostly in the first 2. Okay, nama electric charges and fields, potential and capacitance, adlirunda max to max we can expect 3 to 4 questions. Gravitation lirunda last 2 years, last few years consistent they are asking 2 questions. Okay va? So basically speaking, almost 6 questions you can make sure. In the lecture plus PYQs is definitely going to give you a good score, which means around 20 plus 24, around 24 marks வந்து you can make sure. Find out. இன்னைக்கு வந்து class வந்து around 8 o'clock க்கு finish ஆகும். Okay. Yes. So இப்போ வந்து I have made again mind map தான். You guys know it. என் ஹேண்ட் ரைட்டிங் வந்து அவ்வளோ பெட்டரா இல்லை, ஆனாலும் கம்யூனிகேட் பண்ணுற அளவுக்கு பெட்டரா I feel. So yes or no, is it okay for you people? You can understand, right? I will explain also. Is it okay everybody? Is it okay? Beautiful, thank you. அந்த அளவுக்கு இல்லை எனக்கு தெரியும், ஆனாலும் thank you so much for the compliment Lakshmi. Okay, so இப்போ வந்து first electric charges and fields அந்த chapterல தான் we are going to start. So adula vandu first topic enada electric charges da. I'm not going to write anything new. Whatever I kept some notes over here. In the notes podum, you can just refer even during your examination time. You can just go through it and you can go for the exam. So in the points, in the each and every points which I marked here, adu mattum podum in the chapter la irundhu. Okay vada. So first vandu electric charges da. So when I'm talking about electric charge, adu vandu oru fundamental property da. Correct? It is actually a fundamental property. adu vandu eppavume mass associated ah irukum. Correct? And also adu vandu oru scalar quantity, unit vandu coulomb. Okay, and also I just wanted to let you know guys, I think on 21st I'm planning for a formula revision. I want all the students to attend that session also. Yena the formula revision la we will cover each and every formula from each chapters and the formulas mattum podum, because yena in the 80% of the physics questions la in the formula application irukum illaya. So and the formula you need to by heart, you need to study. Adoda importance I don't know when you will, people will get to know, but marakama and the session vandu you guys have to attend. Okay, yes. So now இது வந்து ஒரு scalar quantity and we know positive charges, negative charges இருக்கு and அந்த two type charges தான் இருக்கு. Next வந்து like charges னா அது வந்து ripple ஆகும், unlike charges னா what will happen da அது வந்து attracted ஆகும். And the major three properties charge is conserved எப்பவுமே for an isolated system. இந்த charge வந்து எப்பவுமே constant ஆ இருக்க போறேன். Understood? Everybody understood? This charge will be always conserved. அப்படினா எப்பவுமே ஒரு சிஸ்டத்தோட charge வந்து same ஆ இருக்க போறே. Second one is it is additive, which means இப்ப வந்து you have three charges. 3 microcoulomb இருக்கு, 2 microcoulomb இருக்கு, -3 microcoulomb இருக்கு. அப்படினா if you wanted to find the total charge, how you will be finding it? What is going to be the value? 3 plus 2 plus -3. Correct? So if there is a negative sign, you have to keep the negative sign ange irukkanum. Yena idu vandu oru scalar quantity da. So if you are just adding this, definitely the negative sign irundiruchuna, you have to keep the negative sign along with it. Purinjidada everybody, yes or no? Please let me know if you understood. Now give me a quick fire in the chat box everybody. A quick fire. Okay, so charge vandu additive in nature, which means in the charges vandu like real numbers you can just add it. Okay, 1 plus 2 plus 3 and the madri q1 plus q2 plus q3. Negative charges irundiruchuna and the negative sign you have to keep it there. Next one, it is always quantized, which means q is equal to ne. This is important relation. Q is equal to plus or minus ne. E oda value, thank you guys, thank you so much. In the E oda value enada 1.6 into 10 to the power minus 19 coulomb da. Okay, so on the value vandu you have to study. Most probably they will give in the question paper, aanalum we cannot take the risk. Correct? So adinala we have to study. Eppovume in the charges vandu integral multiple of in the E value. புரிஞ்சுதா? எப்பவுமே integral multiple of 1.6 into 10 to the power minus 19. Very good Lakshmi, very good. இது வந்து enough for NEET இல்லடா, இது வந்து not enough. Okay, so definitely அதுக்காக தான் we are just doing these lectures na. Okay, so in the lectures எல்லாமே வந்து NEET, if you are preparing for NEET, definitely you should watch these lectures. Okay, very good Arun Prasad. Okay, yes, so now sorry. Okay, so these are the important points which is coming under the what to say in the electric charges 11th. You have to study all these points. Okay vada? Okay, so next month whenever we are talking about electric charge, we have mentioned இது வந்து எப்பவுமே mass associated ஆ இருக்கும். மறக்காம லைக் பண்ணிக்கோடா everybody, மறக்காம லைக் பண்ணிக்கோ. Also share with your friends. We have just started, so in the timeல கூட you can just call your friends. அவங்க வந்து they can also come here. We can do the questions together. அப்போ வந்து ஒரு healthy competition இருக்கும். okay so அந்த competition level வந்து இன்னும் high-ஆ இருக்கணும்னா அவ்ளோ number of students இங்க இருக்கணும் okay அதனால தான் I'm telling you call your friends let them come we can do it together we can work together and we can just keep our level little high okay புரிஞ்சுதா okay yes yes so இப்போ வந்து yes hi Melvina hi okay so இப்போ வந்து we understood இது வந்து எப்பவுமே associated with mass தான் அப்படினா my question is இப்போ வந்து I have two identical bodies okay two identical bodies னா இதோட size shape எல்லாமே வந்து similar தான் அப்படினா இந்த two bodiesல one வந்து positive charge another one வந்து negative charge which one is having more mass A இருக்கு B இருக்கு identical bodies தான் இது வந்து positive charge இது வந்து negative charge அப்படினா A or B which one will be having the mass அதிகமா இருக்கிற mass வந்து it will be more for A or B please let me know quickly yes Shahid it will be B A because this is what A this is what B இது வந்து positive இது வந்து negative so what is the meaning of positively charged body positively charged body na nothing but adile electron deficiency irukum number of electrons வந்து positivity na anga negativity less ah irukum illiyada so adinala I can say that inga varumbodhu positive charge da positive charge nala I can say that number of electrons வந்து இங்கே கம்மியா தான் இருக்கும் number of electrons கம்மினா அந்த deficient ஆ இருக்கிற electrons ஓட mass கூட அங்க இருக்காது கரெக்ட்டா so அதனால I can say that mass of A will be less than that of mass B so mass B na more negativity which means more number of negative charges which means more electrons அப்படினா more number of electrons na we can say இங்க பாக்கும்போது more number of electrons da அதனால அந்த extra electrons ஓட mass கூட இந்த bodyல add ஆக போகுது கரெக்ட்டா அப்படினா definitely இந்த mass வந்து it will be more for the negatively charged body understood so please note பண்ணிக்கோடா right now we have two identical bodies so idhila vandu positive charge irukke negative charge irukke positive and negative charge na I can say that positive and negative charge na I can say that identical body na in the mass vandu for a negatively charged body it will be greater than that of the mass of the positively charged body okay I didn't get you who is that Balaji what is your problem okay yes thank you guys thank you so this is what the important statement please do note it because idu vandu previous year la they have asked so now we have done with the electric charge next one vandu we should know another term that is Coulomb's law or let's say electrostatic okay electrostatic force what is this electrostatic force so ipo vandu I have two charges correct ah ipo vandu I have 2 point charges okay I have 2 point charges so now in the 2 point charges la we have mentioned idu vandu like charge na what will happen da anga oru repulsion da irukum okay so right now you are saying it is wrong what is wrong you tell me okay otherwise please leave the class okay so we know that we have two charges idu vandu like charges na what we will say idu vandu ripple agum so and the repulsion na anga oru force develop aagukella and the force da in the electrostatic force illana in the coulombic force so ipo vandu unlike charge na inga irukkiradhu oru positive charge inga irukkiradhu oru negative charge na when it comes to closer it will be get attracted anga oru attractive force irukella adudha vandu whatever we are calling electrostatic force ipo vandu 2 point charges irundiruchuna adila they will experience a repulsion or attraction and the force da electrostatic force and the value and the force order magnitude will be coming as K Q1 Q2 divided by R square. What is this R? Can you just let me know what is R? Everybody tell me what is R? What is R? So actually வந்து இதுதான் வந்து நம்ம Q1, இதுதான் வந்து நம்ம Q2. Correcta? So distance, always remember, you cannot just simply say distance from the center of the point charges. Okay, ஏனா இது வந்து ஒரு central force தான். புரிஞ்சுதாடா? இது வந்து ஒரு central force தான். Whatever you said is correct. Just be more specific about it. In the 2 point charges la irukra center to center point distance da in the distance of separation. Idu da vandu namma r. Purinjudada? Yes or no? Very good Grishma, very good. Okay va? Both are in the repulsive force, attractive force, and the force is the electrostatic force. Okay, so and the force oda nature vandu maybe attractive ah irukum, maybe repulsive ah irukum. Purinjudha? Okay. Balaji, r vandu radius na very good da, please. Okay, idha vandu you are saying it is wrong. Huh? R na all the time it cannot be radius. Okay, it will be the distance of separation between 2 point charges from the center to center. Everybody understood? Please give me a fire if you understood, everybody. So on the distance vandu careful ah note pannanum. Okay, so idhula vandu we know that in the force will be equal to some constant into the product of the two charges divided by the square of the distance between the two charges from the center to center. Thank you guys, thank you so much. Okay, so now the thing is like in the k value, that is nothing but 1 by 4 pi epsilon naught. This value is valid, or let's say this we can use when we are keeping this two charges in vacuum, illana air. Okay, so ipa vandu the medium vandu air, illana it is actually vacuum na, you can use this expression 1 by 4 pi epsilon naught. புரிஞ்சுதாடா? epsilon naught na அது வந்து permittivity தான். Permittivity na how effectively a material, or let's say a medium, can pass the electric field lines. And note paniko for metals in the value வந்து infinity da. Note paniko, in the value for a metal, okay, and the value permittivity oda value vandu it will be coming as infinity. Note paniko. Purinjudada? So now you got this point. Okay, next one vandu ipo let us say we are keeping these two charges in a different medium na, in the value will turn out to be 1 by 4 pi epsilon m. What is epsilon m? It is nothing but the permittivity in a particular medium. That's it. Purinjadada everybody? What I said? So whenever I am talking about the two charges in vacuum, illana air, and the moment illa, what is this value? K, Q1, Q2 divided by R square. In the K value vandu 1 by 4 pi epsilon naught. Done. So ipa vandu in the two charges whenever I am keeping in another medium, okay, what will happen? In the K value will change, and the K value will become 1 by 4 pi epsilon m. So adakaga you should study one more relation. In the epsilon m will be coming as epsilon naught epsilon r. Epsilon r na relative permittivity ta. Okay, it is nothing but the relative permittivity. So you can just again replace this 1 by 4 pi epsilon naught epsilon r. Purinjudada everybody? Purinjudada? Okay, so idha vantu we should study in the Coulombic law. And also we understood in the value in the Coulombic law la, in the force value vandu it is actually depending upon the medium. Okay, it is actually depending upon the medium. When the medium changes, what will happen? In the value, in the permittivity value will also change. Purinjada everybody? All good, all set? Please let me know in the chat box. If everything is clear, please give me a fire quickly in the chat box. Yes, in air it will be 1. Very good. Yes, perfect. So அதோட வேல்யூ வந்து இந்த எப்சிலன் நாட்டோட வேல்யூ வந்து 8.85 into 10 to the power minus 12 தான். So மறக்காம லைக் பண்ணிக்கோடா. So இந்த கூலம்பிக் ஃபோர்ஸ்ல we understood இப்போ வந்து 2 சார்ஜஸ் மட்டும் தான் இருந்துச்சுனா. Okay? Okay, yes Navishri. Okay. So இப்போ வந்து 2 charges Q1 இருக்கு, Q2 இருக்கு. இந்த distance வந்து R தான். Okay. So in the moment we have mentioned in the force வந்து K Q1 Q2 divided by R square தான். So now the thing is like, let us say we have a system of charges. More than 2 charges irukke. Okay, we have more than 2 charges. Which means I will be placing another charge Q3 over here. Okay vada. So careful note panniko. My question is, so ipo vanda inge oru charge Q3 I have introduced here. Okay, in the Q3 nala the force between this two, which means in the F, I will be mark it as F12. In the Q3 nala in the F12 value will change or not, yes or no. Please let me know quickly. So ipo vanda I have introduced initially on the Q3 ange illa. Okay, right now what happened, I am introducing a charge Q3 over there. அப்படினா இந்த 2 charges illa irukra, I mean due to this 2 charge there is a force developed, right? And the force வந்து change ஆகுமா இல்லையா? Very good Lakshmi, very good. Force of individual charges will not be affected. Yes Grishma, Christina, Durai Zinka, very good, very good. So now I can say that in the individual forces, which means the force between Q1 and Q2 is not going to affect because of Q3. Okay, in the force between Q1 and Q3, because of Q2 and the value வந்து change ஆகாது. Okay, இப்போ வந்து இந்த Q3 and Q2 will also have a force between them. அது கூட it is not going to change because of any new charge. இப்போ வந்து if I am adding thousands of charges over here, okay, thousands of charge over here, ஆனாலும் the force between in the Q1 and Q2 in between there is a force இல்லையாடா, so அந்த force வந்து change ஆகாது. புரிஞ்சுதாடா? Important note, they will ask statement based questions. Got it everybody? If you understood, give me a quick fire immediately. So what I said, இப்போ வந்து இங்க thousands of charges இருந்துச்சுனாலும் in the individual charges, because of the individual charges அதில் இருக்கிற force வந்து change ஆகாது. Thank you da, thank you so much. So first point வந்து it's over. Next my question is, initially நம்ம சிஸ்டத்துல Q இருந்துச்சு, Q1 இருந்துச்சு, distance of separation வந்து R1 தான். அப்படினா இங்க ஒரு force, the net force, okay, the net force experienced on Q, what is going to be that? The net force experienced on Q? Simple ma'am, it is very simple, we already know it. K into Q1 divided by R1 square. Correct ada? Now the thing is like, I am introducing, inga vandu Q irukku, inga vandu Q1 irukku, distance vandu R1 da, inga vandu Q2 irukku, distance vandu R2 da. So now my question is, the net force on Q will change or not? The net force, purinjiko, the net force zero illa, so just focus over here. The net force on Q in this case vandu change aguma illaya? Very good Lakshmi, super. Again, net force experienced by each charge will change. Ana individual forces, okay, எப்பவுமே the force between Q and Q1 வந்து எப்பவுமே it will be same. ஆனா இப்போ வந்து இந்த சிஸ்டத்தினால இந்த Q2 extra chargeனால இந்த Q will experience another force, அதனால net force வந்து change ஆகும். I can see the very good superposition principle is used. Arun Prashad, very good. I can see you people are having lots of energy and you people know the concept point by point. Very good, super. Okay, so ipo vandu we are going for the superposition principle. So let us say, so inge vandu we have a charge Q, here we have a charge q2, okay. So right now we know that the force experienced on q, okay, force experienced on q will be k q this will be 1, okay, q1 divided by, let us say this is r1, okay. Next one I have another charge over here, listen carefully. So idu da vandu nama q2, distance of separation vandu r2, appadina this is due to the first charge and now due to the second charge, okay. In the q charge the force due to q2 will be coming as, can you give me the answer, k q2 divided by r2 square. I forgot to miss this square, okay. So now bye you go, okay. So right now we have k q2 divided by r2 square. Yes, Arun Prashant is also done with you guys. Okay, so yes fine. So we have seen the charge, I mean the force due to q1, the force due to q2. Purinjidada. Now the thing is like, I wanted to know the net force. Individual forces I found it. Okay, individual force I got it. In the q1 inala, what is the force? I found it. q2 nala, what is the force? I found it. Now the thing is like net force, and the net force eppadi, how we will be finding it. அதுக்காக first வந்து எப்பவுமே எவ்வளோ charges இருந்தாலும் பரவாயில்ல, first one வந்து what you are supposed to do, நீங்க வந்து அந்த direction mark பண்ணணும், note பண்ணிக்கோ. இந்த superposition principle use பண்ணி questions they will definitely ask. அதனால தான் I'm telling you, okay, அதனால தான் I'm telling you guys. Everyone carefully paathuko. First point is direction you have to mark. Evlo charges irundhirchalum paravailla, you should mark the force. Okay, so in the direction paakumbodhu idu vandu or positive charge, idu kuda or positive charge. Now my question is, what is the net force? Okay, so I just wanted to know in the q1 inala, okay, in the q1 inala, in the q charge will experience an attractive or repulsive, A or R, okay, attractive or repulsive. Can you just give me the answer? In the q1 inala, q experience பண்ற force வந்து attraction illa repulsive? Quickly. Attraction illa? Yes, it is repulsive. Why? Yena adu vanda like, very good, great king, right? Very good. Adu vanda it is actually like charges da. Appadina tell me in the q will experience a force towards my right side or towards my left side, right or left. Very good. Grishma, mostly vanda, I mean it will be in English, but still I have to go for Tamil. My Tamil is also very weak, okay, so I don't think there will be a problem for you, okay. So this will be, idu vanda repulsion illada, repulsion, idu vanda q1, idu vanda q, so repulsion na it will move away. So appadina I can say that in the force order direction vanda it will be like this, and always in the force order direction vanda the line connecting two charges la irukum. And exactly the similar way, idu vandu or positive charge, idu vandu or positive charge, again vandu repulsion da. So now we will be getting the other force. So let me just mark this as F1, this is as F2. Idu vandu F1, this is nothing but F2. Appadina I have to go for the vector sum. Purinjidada, I have to go for the vector sum of all the individual forces. Appadina the net force on Q will be coming as the F1 plus F2. Next one, in the resultant, how we will be finding the resultant? How we will be finding the resultant? How we will be finding? Yes, great king. Today we will be dealing with the NEET and JEE previous year questions. Okay, and in the upcoming weeks we have clearly giving you some separate sessions. Okay, in the AIMS JIPMER exam, so adukellame theviyana type questions vandu separate we will do. Okay, ஏனா நம்ம community வந்து mixed students இருக்கு. So உங்க priority basis you can just choose the class. So இது வந்து 100 plus series தான், which means physics la வந்து you can make sure 100 plus by the end of the series. புரிஞ்சுதாடா? Okay, so that is what the thing I have mentioned. So இப்போ வந்து 100 plus na உங்க target na இந்த sessions வந்து you can just focus. இதுல வந்து high weightage chapters மட்டும் தான் we will focus. Okay, நாளைக்கு வந்து current electricity இருக்கும், semiconductors இருக்கும். So you can just watch that also. இப்போ வந்து இந்த question practice na அது வந்து after 20th. Okay, after 20th you will be having the question practice. அது வந்து different types இருக்கும். As I mentioned, இந்த high level questions இருக்கும், medium level questions இருக்கும், easy scoring questions இருக்கும். எல்லாமே வந்து separate sessions இருக்கும்டா. Is it okay? Great king, fine. Okay, yes, I have marked on the right side. No, this is my right side. Okay, okay, ஏனா அது வந்து it is actually repulsive. Okay, repulsive tha, so in the q1 will repel it. Okay, so now இதுக்காக you will be using the resultant order magnitude. You will be finding using this equation a square plus b square plus 2ab cos theta. புரிஞ்சுதாடா everybody? Okay, so this is how you should do it. So இப்போ வந்து 4 charges இருந்துடுச்சா கூட what you will do, so இதுதான் வந்து நம்ம 4 charges we kept it like this, q1 q2 minus q3 and q4. Now the question is, what is the force experienced on q1? அப்படினா first வந்து what you should do in the q2 direction வந்து mark பண்ணனும்ல. In the q1 and q2 na like charge da, like charge na what will happen, repulsion da. So this is what f12. Okay, so next வந்து in the q4 and q1 அது வந்து again repulsive da. So அதனால again we will be having 1 4. next வந்து இங்க ஒரு charge இருக்கு, கரெக்ட்டா? அது வந்து minus q3 தான். So what will happen da, இது வந்து q1 positive, அது வந்து minus q3. Attractive or repulsion, please let me know. Attractive or repulsion in this case? Attractive or repulsion? Please let me know. Quicker tell me, q1 and minus q3, there is a force between them. Is it going to be attractive? Very good Lakshmi, very good Aparna, it is coming as attractive. So I can say that will be towards this minus q3 will pull this q1. So I can say that this is what the f13. So in the madri first one you have to go for the direction, mark all the direction, adukapra you can just go for the resultant finding equation. Okay, so now we will be going back to this. Okay, so now we have understood all those things. Next on the electric field da. So in the electric field la, yes, of course we will solve problems also. Okay, and guys marakama like panikoda, because later on also you can just come. So in the sessions la vandu interaction I have made it very less, because yena again after some time also you are supposed to watch this and you have to get all the information. So adanaala interaction vandu kammi da irukke. So adanaala you can like this video even if you cannot complete it. Okay, purinjudha everybody? So marakama like panikoda, don't be so selfish. Okay, yes. So ipo vandu electric field da. So in the electric field na ennada, it is nothing but the net force experienced by a unit charge. So simple as onna inga varumbodhu oru charge q irukku. So in the q oda influence irukku. Okay, in the points la ellame vandu q oda influence irukku. So ipo vandu if you need to find the electric field at any point, careful ah purinjukko, ipo vandu you should find the electric field at any point. Got it? Electric field at any point na, and the point la question vandu idudha, electric field you have to find it for a particular point. And the question pathena, first thing what you should do, and the point la, so ipo vandu inge da irukke. Okay, idudha vandu point p. In the q charge nala what is the net force, or let's say electric field experienced at the point p na, first you have to keep a test charge over there. What is test charge? Now, what is test charge? That usually we will be take it as positive charges, and also adoda magnitude 1 unit irukkanum. And note panikoda, even if I am saying 1 unit charge nalum adu 1 coulomb aga mudiyadu. Okay, note paniko, even the test charge I used to mention magnitude 1 unit, even though it cannot be 1 coulomb because 1 coulomb itself is a huge charge. Around 6.25 into 10 to the power 28 electrons irukum in 1 coulomb, which means that is also a huge charge. அதனால இந்த டெஸ்ட் சார்ஜ்னா அது நானோ கூலம்ல இல்ல பைக்கோ கூலம்ல இருக்கணும். ஓகே, சோர்ஸ் சார்ஜ்னா இருக்கிற ஒரே ஒரு சார்ஜ். ஓகே, சோ இங்க வரும்போது இந்த Q மட்டும் தான் இருக்கு. சோ அந்த Q மட்டும் தான் அங்க இருக்கும். Understood everybody? So this is what the thing. So inga ஒரு Q charge இருக்கு, and we need to find the field at any point na and the point illa you can keep a test charge. You can keep a test charge. Understood everybody? Understood na? Give me a quick fire everybody. So appadina I am just going to define this electric field with a very simple equation. This Q naught tends to 0, F divided by Q naught. Why we are giving limit Q tends to 0? Why we are giving the value for Q naught? Ena test charge avlo small irukkanum. That is what I said. Even 1 coulomb is also not possible. In the Q naught oda value in the Q naught oda value innum small ah irukkanum. Adinala da we are giving this limit Q naught tends to 0. Okay, purinjada? So we can say that electric field will be coming as F by Q naught, and the Q naught oda value it should be very small. Appadina for a point charge, okay, appadina for a point charge in the electric field oda value will be coming as KQ divided by R square. Very good, Arun Prasad. It should be nano, pico, that must be the range. Very good. So now the point for a point charge in the electric field KQ divided by R square. Okay, Q na, that is what I said, source charge. It is not in the electric field it is not depending upon the test charge. Okay, we are not considering about the test charge when we are talking about electric field. Electric field due to point charge will be KQ divided by R square. So ipo there are there are few more electric field that you should study, and as I mentioned, I'm not going for any of the derivation. Few derivations are we have already done. Okay, in the electrostatics or a detailed session we have already marked it. So now the thing is like you should study some of the electric field by heart. So adukku munnadi you should know one thing. Ipo real life you cannot find this point charge. Okay, we always see what is a continuously charged bodies like a wire, sheet, sphere. So idellame in the charge it will be uniformly distributed. Correct? So appadina we cannot just use this equation in the KQ by R square we cannot work it out. So adakaga we are studying some new terms. Okay, we are studying some new terms. Just ignore that, just focus over here. Okay, so now the thing is like you should study these terms: linear charge density, surface charge density, as well as the volume charge density. So lambda na, it is nothing but linear charge density, the charge per unit length. So appadina tell me da, what is sigma? What is sigma? What is sigma? Everybody tell me, what is sigma? That is nothing but dq divided by dA. Okay, dq by dA. Next one rho. Rho na ennada volume charge density da. That is nothing but dq per, the charge per unit volume. In the terms you should do. Okay, very good. Okay, who is that? Entrance assistant. I hope I have clear. Yes. Okay, so in the three terms vanda you should know, because we are going to find it for different cases. So first one vandu paakumbodhu finite wire. So ipo vandu we have a wire. So idhula vandu charges irukke. So in the wire oda length vandu we know it. Okay, in the length vandu we know it. Appadina you can use this equation. I hope it is visible. K lambda divided by r sin theta 1 plus sin theta 2. So just this is the road. Okay, illana this is the wire and this is the point where you need to find the field. So first vandu I will go for a perpendicular line from the wire to the point where you need to find the field. This is what r. Okay, so it is not just about studying the equation, it is all about understanding each term. So understand in the case what is r da, in the wire la irundha point p la irukra perpendicular distance da. Understood? Perpendicular distance da. Next vandu from one end we will be draw a line, from here we will draw a line. This is what theta 1, this is what theta 2. Appadina electric field at p will be coming as k lambda divided by r sin theta 1 plus sin theta 2. Purinjidada each and every term. Understand what is theta 1 and theta 2. We will draw a line from one end to the other end, that will be theta 1, and this one that is going to be theta 2. So now the thing is like you will be getting the electric field as k lambda by r sin theta 1 plus sin theta 2. So guys, marakama like panikoda, don't forget to like this video. Yena again after some time also you can just check out this video. Done? Everybody done? Please let me know. Understood? Now give me a fire quickly. So idukapram I am going to ask you a very simple question. Very simple question. So the question is, right now what I said, idu vandu oru finite da. Okay, idu vandu finite length da. So now let us say, if I am increasing the length, what will happen to theta 1 and theta 2? Will it increase or decrease? I'm repeating my question. Okay, I'm repeating my question. Carefully paathuko. So ipo vandu in the length increase aachna, in the wire oda length increase aachna, what will happen to theta 1 and theta 2? Very good Shahid, it will increase. Just imagine ipo vandu ippadi da irukke. So innum length adhigam aachna, this will be go like this, go like this, go like this, go like this. Appadina very good, very good. Appadina if it is infinite, okay, if it is infinite, this angle theta 1 and theta 2 will become 90 degree. Are you guys getting it? Are you guys getting it? Understood? So in the length increase aachna, at some point this will increase and it will come to 90 degree. Appadina substitute here and tell me what is the electric field you are getting. Okay, just substitute theta 1 and theta 2 and tell me what is the electric field now you are getting. Very good, very good. So for infinite in the theta 1 and theta 2 will become 90 degree. So in the equation I am going to make some change, that is nothing but sin 90 plus sin 90. Sin 90 vandu 1 da, 1 plus 1 2 da. So we will be getting 2k lambda divided by r. So idu da vandu in the Gauss law apply pandradhukku appuram we are doing it. Okay, understood? Purinjida? So now we got it for the finite as well as infinite. Next on the circular arc da. Okay, circular arc na ippadi da irukum. Okay, so idu da vandu r, idu da vandu alpha. Appadina you can say that, where is it? Okay, so it will be coming as 2k lambda divided by r sin alpha by 2. Okay, I mean very good. Khalifa, right? If I'm not wrong. Simple da, and the sign in the equation la theta 1 ku you can just substitute 90 degree. Okay, when it is infinite that will become 90 degree. Just substitute da. Yes, Kashifa, yes. Okay, so now we got it for the arc as well. So in the equations ellame vandu you can just by heart. Okay, as I mentioned, no need of any derivation, anything, you can just better study. Okay, for infinite I have told you. For finite in the equation in the theta 1 and theta 2, if you know, you can substitute. If on the infinite na, theta 1 will be 90 degree, theta 2 will become 90 degree. Semi infinite na, what will happen? Again, which side is in in the infinite arc, on the side la, you can put it as 90 degree. Okay, so now circular arc vandu purinjiduchu. Next vandu ring da. Okay, ipo vandu we have a circular ring. So இந்த மாதிரி தான் circular ring இருக்கு. இதுல வந்து radius r இருக்கு, and from the center there is some distance x. I am finding a point p, and in the distance வந்து r. Okay, so in the circular ring நால, okay, in the circular ring நால what is the field at the point p? அதுதான் வந்து question. Understood? What is the field at this point? So adikaga you can just use this equation, kqx divided by r square plus x square all raised to 3/2. So in the equation kuda important da, you guys have to study. Okay, understood na? Quickly give me a fire da, quickly, because you people, I feel like you people are sleeping, not giving any reply. Okay, so quick you can give me a fire, so I will also get some energy. You will also feel like, yeah, I'm back to the class. Yes, fine. So இப்போ வந்து circular ring na, அதோட radius வந்து capital R. In the center la irundha in the point p na enna field. Okay, we need to find the field, correct? And the field oda the distance வந்து x da. Appadina you will be getting the field like this. Now my question is, yes, exactly same as magnetic field. So when I am discussing magnetic field also, I will just have a comparison. So inneki vanda I have did the same thing for gravitation. I'll show you later. Why we are just wasting our time right now? We will anyway going to see now. So ipo vanda idudha vanda equation for a circular ring. Now tell me, at the center la what is the field? What is the field at the center? Quick tell me da. Tell me what is the field at the center according to this equation. Center na x value enna? Very good. X value will be 0. So field at the center will also come as 0. Next one more point that you have to study. When we will be getting the maximum electric field, what must be the x value? Very good. What must be the x value? X value must be plus or minus r by root 2. Okay, when the x value is becoming r by root 2, you will be getting the maximum electric field. Note pannikoda, adoda derivation ellame vandu you can skip it. Just focus over here. So ipo vandu if you need to find, ipo I have given a ring for you. அப்படினா அந்த ரிங்னால where you can find the maximum field, where you can find when x is equal to r by root 2, and the value kuda you should study. Okay, so next one வந்து we have studied all those things. Next வந்து spherical shell da. Okay, spherical shell na last point da. Last point enna what is it? What I said the last point? I even forgot. Completely gone. Okay. Field will be maximum. Okay. Field will be maximum when the x value is equal to r by root 2. Okay. Illana hollow sphere. Appadina what is the meaning? So on the inside vandu mass illa. Okay. Inside vandu mass kedaiyadu. So hollow sphere illana spherical shell. So in the word now you should understand mass is equal to 0 inside. And just now only we have mentioned, when we had started this lecture we have mentioned, in the mass, in the charge vandu mass irundha mattum da charge irukum. Okay, and the mass irundha mattum da charge irukum. Appadina tell me da inga irukra inside la irukra electric field, what is going to be that? எப்பவுமே நோட் பண்ணிக்கோ, இந்த சார்ஜ் வந்து ஆல்வேஸ் அசோசியேட்டட் வித் மாஸ் தான். அந்த மாஸ் இருந்தா மட்டும் தான் சார்ஜ் இருக்கும். ஹோலோஸ்பியர்னா இன்சைட் நத்திங், நோ மாஸ் நத்திங். அப்படினா அங்க இருக்குறதுல very good Aparna, very good Arun Prasad. So it will be coming as 0. And surface ila varaporadhu k into q divided by r square. And the capital yarna, that is nothing but the what to say and the radius. Okay, outside point na it will be kq divided by r square, which means ipo idudha vandu nama holosphere. So in the center la irundha in the distance, this is what r. புரிஞ்சுதாடா? So in the values வந்து you have to, yes, very good, radius of the sphere da capital R, small r na from the center to the distance. Okay, distance to the point where you need to find the field. Okay, so now next வந்து solid sphere da. Solid sphere na inside mass இருக்கு. Okay, solid sphere na inside mass இருக்கு. So now the thing is like mass இருக்குதுனால I can say electric field at the surface and electric field outside the point வந்து same as holosphere da. Okay, same as holosphere da, which means this will be kq by capital R square and outside வந்து kq divided by small r square da. ஆனா inside வரும்போது there is a small change, kqx divided by r cube it will come. Okay, kqx divided by r cube it will come. Okay vada, x na very simple, where I have written this. Okay, x na very simple. So now we need to find a point inside, right? So inga vandu we will be consider a Gaussian surface. So in the distance da x. Understood everybody? Please let me know, give me a quick fire if you understood. Quickly you can give me a fire. And marakama like panikoda. Understood everybody? Yes or no? Yes or no? Yes Abarna, yes Lakshmi. Okay, thank you so much. So idu da vandu we were just discussing right now. Next one vandu innum important ana oru concept da, for an infinite plane sheet. Okay, for an infinite plane sheet, this electric field will become sigma by 2 epsilon naught. Sigma by 2 epsilon naught. So in the value kuda you have to study for the electric field. Ivlo da actually vandu you need to study. Okay, this is what the different electric fields you should study. Next one, the null point. Okay, you need to find the null point. Null point, if you need to find the null point na, you can just straightly use this equation, d divided by root of q2 by q1 plus or minus 1. Like charges na you can just keep plus, unlike charges na you can just keep minus. If you are feeling like ma'am I can't study this and all, okay, no worries, you just see here. So inga vandu q1 irukke, inga vandu q2 irukke. Okay, so where we are finding, we are going to find the null point, which means on the field vandu it should be cancel each other and we should get 0. So adinala you can find the electric field due to the q1 and you can find the electric field due to q2. And you can equate this. So appadina what will happen? K q1 divided by, I'm just assuming at this point, okay, let us say this is what x, this is what the distance of separation. Appadina this will be x square, which is equal to k q2 divided by d minus x the whole square. Okay, so enge we need to find the null point. Okay, where you need to find the null point, on the point la you can keep a test charge. Okay, so right now due to q1 nala in the point la irukra field da E1, due to q2 there will be a field that is k q2 divided by the d minus x the whole square. Purpose is there in the question itself, null point, the field is 0 agra point. Okay, that's it. Understood? Done? So now we got this one, and you have to understand few things. Ipo on the like charges na, okay, like charges na, first point is in the null point. Note panniko, null point will be in between these two charges. Okay, like charges na what is happening? Like charges na what is happening da? In the null point vandu in the two charges ku in between da irukum. இப்போ வந்து இந்த charges வந்து Q1 is large and Q2 is small. Okay, magnitude wise பார்க்கும்போது இந்த Q1 தான் அதிகமா இருக்கு. அப்படினா this point will be close to Q1. Enge we have the bigger charge and the null point will be close to the bigger charge. While you are solving the problems, these are the things which is going to help you. So note panniko, if it is like charge, the null point will be in between and it will be close to the bigger charge. First point. Second one, the unlike charge da. Okay, unlike charge da, definitely it will be outside the 2 points. Not panniko. So what I said when I am talking about unlike charges, in the null point vanda, it is not in between the two charges, it is actually outside the point. Then next vanda, in the case la kuda, even if it is like unlike, it is supposed to be close to the bigger charge. Understood? So ipo vandu idu like charge da, so that is why I have kept this in between, and let me say charge Q1 is greater than Q2, that is why this is close to it. Now I have another one, Q1 irukke, Q2 irukke, this is one the minus Q2 da, and also Q2 oda magnitude da large irukke. Appadina, where you can find the null point, can you just let me know in the chat box where you can find the null point? Quick, you can tell me where you can find the null point. Outside the, very good Lakshmi, and near to Q2. So inga da actually vanda in the null point irukum. In the points e podumda question, null point question vanda easier you can crack it. So ipo vanda paakumbodhu nama first session vanda mudinjiruchu. Next we are quickly going for the second part. Okay, so in the second part la what are the things we have? Okay, so first one you should know about the electric field lines, adoda properties. I have marked everything here. Okay, so idu vandu imaginary lines da, idu vandu representing electric field, number of field lines one, it is giving you the idea about the field is strong or weak, and always when the positive la irundhu it will end to the negative, it will never ever form closed loop. Tangent vanda, it will be giving the direction, and this field lines will never ever intersect. Why it is not intersecting da? Why it is not intersecting? Yena and the point la two direction irukum, that is not actually possible. Marakama like panniko. Yena later on also you can just go back and you can just come here, you can study this. Adanala I am telling you. So after some time in the regret edukkum possibility illada. So adanala like this video right now, marakama subscribe kuda pannalam. So next one the electric flux da. So ipo vanda you have studied about the field, correct? In the field lines vanda, very good Arun, very good. Okay, so ipo vanda field lines vanda you got it. So flux na in the field lines mattunda. Okay, there is no much change. Ana in the field lines vanda, it should pass as perpendicular to the surface. Okay, whenever we are giving any new name na adukku vanda edacha small change irukumla. So andha madiri flux na flow of electric field da, or flow of electric field lines da. ஆனா அந்த field linesக்கு வந்து கொஞ்சம் ஸ்பெஷலா இருக்கணும். அந்த ஸ்பெஷாலிட்டி என்னன்னா, it should pass perpendicular to the field. Yes da Shahid, இந்த கிளாஸ்க்கு அப்புறம் கமெண்ட் பாக்ஸ்ல you can find this PDF. Okay, so it is actually the field lines should pass as perpendicular to the field, and அதோட expression வந்து it will be coming as E dot A. Flux வந்து ஒரு scalar quantity தான். Okay, flux வந்து ஒரு scalar quantity தான். So now I can say that flux will be E dot A, dot product. Okay, dot product na அங்க வரும்போது we will be getting it as EA cos theta. Now tell me da, what is this theta? Tell me what is theta. Quicker you can tell me. What is this theta? Everybody tell me. Everybody. Yes. Tell me. What is theta? Theta is nothing but the angle between field vector and the area vector. Now tell me what is the how we will be finding, okay, in the area order direction, how we will be finding it. Please let me know how we will be finding the direction of area. Area வந்து ஒரு vector quantity. அப்படினா அந்த area ஓட direction, what is going to be that? Very good Aparna, very good, superb. So it is actually perpendicular to the surface. So இப்போ வந்து இந்த surface இப்படினா I can say that this is what the field, I mean in the area vector ஓட direction, perpendicular to the surface. Understood? Got it? Yes, very good. அப்படினா அந்த area vector and field vector will be producing an angle, that is what theta. இப்போ வந்து இந்த field வந்து uniform இல்ல, okay, அது வந்து non uniform னா flux வந்து you will be find it as closed integral or let's say integral E dot dA. Next வந்து இதிலிருந்து you are going to find the Gauss's law. What is Gauss's law is talking about? Closed integral E dot ds, which means flux, okay, which means flux, which is equal to Q by epsilon naught, okay, 1 by epsilon naught, the charge enclosed inside the Gaussian surface. Purinjadada everybody, yes or no? Give me a quick heart if you understood. So Gauss's law na, it is nothing but the closed integral. Yena the Gaussian surface vanda, it should be a closed surface, 3D arkanum, and that will be equal to the charge enclosed in the Gaussian surface divided by epsilon naught. Okay, so next one, you should know about the Gaussian surface. Whatever be the point I have marked here, many students doesn't even know about it. They will make mistake. That is why I have written all the important points over here. Marakama, everyone should note it. Hi Oliva, hi. Okay, so flux through the Gaussian surface is independent of the shape, which means you can choose any shape for the Gaussian surface. It is not necessary that you should take a sphere. It is not necessary that you should take a cube. These are all not at all necessary. It should be always independent of the shape. Okay, Gaussian surface or a shape, you can take it any shape and that will be independent. Next one, it is definitely depends upon the charge inside. I'm okay, I'm a good Goliva. Okay, so first one, yes Arpida. Yes, that is the logic Aparna. So now you can just ask me, ma'am, in the applications of Gauss's law, whenever we are just taking the sphere, we are considering the spherical shape as a Gaussian surface and all. The thing is like, why we are using Gauss's law? In the field non-uniform aayadinala, we need to find it in an easy way. So at the time you cannot find any shape which you don't know the area. That is not possible. Correct? So adinala we are choosing the shape which we know the area and it is easy for us to find the field. That is what the thing. Okay. So next one independent of the position of the charge. In the Gaussian surface in the charge enge irundalum paravalla, that is not at all depending upon. Next one, all charges present contribute to the intensity of electric field at the Gaussian surface, and incoming flux usually we will mark it as -5, outgoing we will be considered as +5. Next one, in the phi is equal to flux 0, that doesn't mean like field is equal to 0. Ana field 0 na adoda meaning flux 0 da. Field 0 na charge will be, the net charge will be 0 da. So adinala we can say flux 0. Okay, so this is what the another thing which you should know. Next one, quicker we can go for the, or before that let us just go for some 5-6 questions. Adukapra we can come back and we can just do this again. Will it be fine? Everybody, is it okay na? Give me a fire quickly. Questions na, because we need to cover three more. Okay, so now you can just tell me. Let's do some questions da. Otherwise na we will feel exhausted. So first question inge irukke. So quicker, you can just do this question. Everybody. So Marakama like panning everybody. I want your likes. Quickly you can give your likes please. So what is here? So the electrostatic force on a small sphere of charge 0.4 microcoulomb due to another small sphere of charge minus 0.8 microcoulomb in air is 0.2 Newton. What is the distance between the two spheres? So in the question வந்து அவ்வளோ ஈஸியா இருக்கு. So just we need to use this equation k q1 q2 divided by r square. So r will be coming as root of k q1 q2 divided by f. So quick வந்து you can just do the substitution. Quick வந்து you can just do this. Quickly calculation. So இதுதா வந்து the equation k value வந்து 9 into 10 to the power 9, q1 is 0.4 into 10 to the power minus 6, q2 is 0.8 into 10 to the power minus 6 divided by 0.2 and you can find the root, it will be giving you the answer. Quickly. Please do it on, you should increase your speed. Okay. So in the question we cannot just do, we cannot take more than 45 seconds. ஏனா இதல வந்து concept avlo you don't need to think, just you need to substitute, do the calculation avloda. And guys marakama like panikoda. Quickly you can do the like. Yes. So option B is coming as the right answer. Very good Christina. Okay, so inga vandu calculation irukku. As I mentioned, we will be just using k q1 q2 divided by r square, which is equal to the force. Very good guys, very good. You are doing in a very short time. Next one, if two same charges 3 into 10 to the power minus 7 coulomb and acted upon by a force 2.5 Newton, the distance between them if both the charges are in vacuum. Okay, so if it is not mentioned, இப்போ வந்து இந்த questionல they didn't mention about vacuum or air, அப்படினா you can choose it as vacuum or air. Okay, if it is specified, you should use the equation accordingly. So in the questionல கூட same as previous one, k q square, ஏனா q1 and q2 வந்து same charge தான், divided by r square, which is equal to force. Force ஓட value வந்து 2.5 தான், k again 9 into 10 to the power 9, q வந்து 3 into 10 to the power minus 7 divided by r square, and the r square da you need to find and you should go for the root. Quickly you can give me the answer. Same equation. இன்னும் செல்ஃபிஷா இருக்கிற ஸ்டூடெண்ட்ஸ் இருக்கு. They didn't even give me the like. I don't know why. Okay. No issues, but do this question. Yes, Christina. Yes, it will be coming as 0.018 meter. Very good. Shahul, you just do the calculation again. Maybe there was some kind of error. Okay, do the calculation again, but no issues. Make mistakes, do maximum number of mistakes in these 25 days, because exam time we don't have we don't have an option to make mistake. So adanala make mistake, understand from the mistake, learn from it, do not repeat. Okay, very good. So now another question. Okay, potential energy straightly coming. Let me just go for the potential, dipole. All the questions were from dipole. Okay, so this question is fine. When a piece of polythene is rubbed with wool, a charge of -2 into 10 to the power -7 is developed on polythene. The mass transferred to the polythene is mass transferred. Okay, so charge we know, mass of an electron we know, that is nothing but 9.1 into 10 to the power -31 kg. So adilirundu you can just find the answer for this question. Okay, so mass of electron 9.1 into 10 to the power -31. You can do the calculation now. Do the calculation again. We have the charge over here -2 into 10 to the power -7. Okay, this is what the charge we have, and you can find the number of charges, number of electrons transferred from it. So for that you can just use the Q is equal to NE. So Q by E will be giving you the N. Once you get N, you can just multiply it with the mass of electron. So this divided by 1.6 into 10 to the power -19 will give you N. Adukapram you can just the N value into 9.1 into 10 to the power -31 kg. Very good, Christina. Very good. So the answer will be coming as 11.38 into 10 to the power -19. Very good. Christina is too fast. Others, you should have more speed. Otherwise we will be always, what to say, எப்பவுமே we will be in the back. Okay, ஏனா எக்ஸாமுக்கு it is not about the it is not just about the accuracy is having high what to say, importance, but aduvida we should also make sure we are doing the questions in 45 seconds. Yes Durai, then I missed it. Sorry. Okay, yes Lakshmi, very good. So now let us move on to the next question. The rate of alpha particle falls on a neutral sphere is 10 to the power 12 per second. The time in which the sphere gets charged by 2 micro, this is actually coming as micro Coulomb is. So we need to find the time we need to find it. Can you find it? So idukkaga first we can just find the total charge of an alpha particle. The charge of an alpha particle, which means adula we know it is as similar to the helium nucleus. Appadina 2 into 1.6 into 10 to the power -19 in the charge varapore. Correct ada? Yes or no? That is what the charge. And next we can find the charge rate, as we got Q into 10 to the power 12 will give you the charge rate. Adukapram you can find the time. Microcoulomb divided by the charge per second. Charge per second, how we can find it? We know that the total charge will be coming as 1.6 into 2 will be 3.2 into 10 to the power minus 19 into 10 to the power 12 will be giving you the charge per second. Yes, Lakshmi and Christina and Shahul, right? Yes. So I think this time I didn't miss anyone. Okay, so the answer will be coming as 6.25. So all questions or detail on a solution I have pasted here. So if you are finding any difficulty on the solution, you can just go through it. Okay, in the session you will be getting the PDF, so you can just check it out. Okay, Shahid. Okay, Shahid. So next is a charge Q is divided into two parts. Okay, Q is divided into two parts. Then they are placed at a fixed distance. The force between the two charges is always maximum when the charges are. So in the Q1 it is changes to Q1 and Q2. Correct? So you should know whenever we are placing this Q1 and Q2, we should get the maximum value. Maximum force we should get it. So maximum na, okay, maximum na, what we should do we should go for dF divided by dQ1, that should be equal to 0. Appadina we know that Q1 plus Q2 charge is conserved illada, so adanala I can say that Q1 plus Q2 which is equal to Q da. Appadina very good Durai Singh. Okay, very good. So in the Q1 plus Q2, in the charge split to two different charges Q1 and Q2. Appadinalum total whenever we are summing up, we should get the capital Q. And now what happened? I can just write Q1 as Q minus Q2. Illana I can write Q2 which is equal to Q minus Q1. Now I am writing the force order equation. What is going to be the force order equation? K into Q1, and what is Q2? It is actually Q minus Q1 divided by R square. And what is the question? We need to find the maximum force. Adukkaga we can just differentiate and we can equate it with 0. While we are doing this, we will be getting the value as Q by 2 and Q by 2. Even if you are feeling like ma'am in the process so in the madri ore question da varapore, we will be getting the maximum when the charges are equal, which means the charges must be Q by 2 and Q by 2. So you can just even study in by heart. That will also help you to solve this question. Eppume you can study as a statement. We will be getting the maximum force when the charges is Q by 2 and Q by 2. Okay, other than what I said, if you are feeling like this, you can't understand. This answer is Q by 2 da irukkum. Okay, and the charge half irukkanum, and the value it should be half. Is it okay? Any issues with the video, audio, anything? Please let me know, guys. Any issues? Because the system got off for a second, that's why I'm asking. No issues, perfect. So in the question, if you need to do it now, this is the process I have mentioned. Total number charge Q da. That is split as Q1 and Q2. In the Q1 and Q2 value we need to find it when we are getting the maximum force. What must be the value of Q1 and Q2? This is the question. So we know, we can directly write this relation. Correct? Q1 it will be equal to Q1 plus Q2. Now the thing is like you should write the force. What is the equation for force? K into Q1 Q2 divided by R square. So what I'm going to do, I don't know what is Q2, I don't know what is Q1. So in the equation we have two different unknowns. Correct? Q1 and Q2 irukku. So adanal we cannot just simply find the answer. Adukkaga what I did, I have replaced Q2. Q2 I found it from this equation. Okay. So on the Q2 I have given this expression. Now I will be getting K into Q1 Q minus Q1 divided by R square. Next process is you have to differentiate this, which means d by dq1 of k q1 into q minus q1 divided by r square. So idhula vandu paakumbodhu k and r square vandu constant da, so you can just take it out. Next one vandu we have q1q as well as minus q1 square. Next one is you should do the differentiation, and while we are doing the differentiation and we will be equating it with 0, ஏனா basic mathematics la we are studying illada in the maxima, when we will be getting the maxima the first differential should be 0. So andha madri we will be equating it with 0 and we will be getting q1 is equal to q by 2, q2 is equal to q by 2. If you are feeling in the process the difficult na, skip this, study the answer. Ipa the charge q na, the maximum force you will be getting when the charges q1 and q2, q by 2, q by 2. Illana, you can just do this method. No, I mean there is nothing new in it, and the basic mathematics illa whatever we are studying adha vandu inga we are applying. Okay, so that is what the thing. Next question. Two charges of plus 4 microcoulomb and minus 16 microcoulomb are separated from each other by a distance of 0.6 meter. At what distance should a third charge of plus 6 microcoulomb placed from plus 4 microcoulomb so that the net force exerted on it will be 0? Okay, so in the question first we can understand what is given in the first line. We have two charges, correct? Okay, we have plus 4 and we have minus 16. Idudha vandu the charges we have separated by a distance that is given 0.6 meter. At what distance should be a third charge? I wanted to place a third charge over here. Okay, I wanted to place a third charge over here. Let me just call it as, that is given 6 microcoulomb placed from 4 microcoulomb. So inge irundha, so this is what the x distance, the net force exerted on it will be 0. So in the madri question again what I have mentioned, first vandu in the plus 6 experience pandra force oda direction da work pananum, correct? So plus 4 irukku, plus 6 irukku. Okay, now I am just focusing on these two charges. So now my question is, in the plus 4 microcoulomb charge nala, in the plus 6 microcoulomb will experience attract or repulsion? Please tell me quickly, everybody tell me. In the plus 6 microcoulomb da inge irukke, so definitely it will be a repulsion. Idu vandu it will force towards this direction, correct ada? So now I am just marking that as F1. And next vandu inge irukkiradha minus 16 da, correct? So definitely what will happen, idu vandu minus 16 and this is nothing but plus 6. Appadina what is going to be the direction? What is going to be the direction? Tell me. Adu vandu attraction irukum, so that is again coming to the same direction, which is not possible, right? So appadina what should be the charge da? What should be the charge? Can you please let me know? So ipo vandu if you are marking the force like this, what should be the charge? So you can just tell me. What should be the charge? So now the thing is like this should cancel each other. So I can just say that F1 must be equal to F2 and this should be at this point. Okay, we have already, what happened? So inge irukkiradha plus 4 illada and this is what 6. So this is going to be repulsion due to plus 4, correct illaya? Is there any confusion? This will be towards my left side due to plus 4. Am I right or wrong? Okay, and inga varumbodhu minus 16 da, so adu kuda it is going to be attraction. Okay, that is what I was asking. So where we should keep the 6 microcoulomb charge. Where we should keep the 6 microcoulomb charge to cancel the force. To cancel the force, where we should keep. So I can say that this we can just keep it over here. Okay, so what will happen? What will happen? So in the plus 16 nala idu vandu attraction da, and due to this plus 4 this will be repulsion da. Appadina in the distance alla we should take it. We should take this distance. We should take this distance. Okay, idu da vandu x. Okay, and this distance will be coming as x minus 0.6. Understood? Now the thing is like, puriyalaya? Should I repeat again? Okay, yes or no, please let me know. So now the thing is like, we can just go for the expression k into q na 4 into 10 to the power minus 6 into 6 into 10 to the power minus 6 divided by x square should be cancelled with the other one. So k into 16 into 10 to the power minus 6 into 6 into 10 to the power minus 6 divided by x minus 0.6 the whole square. Okay, so now I'll explain one more time. So right now we have plus 4 microcoulomb, and at a distance 0.6 meters we have minus 16 microcoulomb. Correct? So now the thing is like, we should keep another charge that is nothing but 6 microcoulomb. So whenever we are placing the 6 microcoulomb, okay, whenever we are placing the 6 microcoulomb, the force due to plus 4 and minus 16 should cancel, which means the net force, that is what is asked in the question, right? The net force must be 0. Okay, the net force exerted on it will be 0. So appadina we should keep somewhere around here. Okay. So otherwise the force won't cancel, no da. Force should cancel, right? So inga vanda if I am placing in between, now what is happening? In the plus 4 nala it will be experiencing a force in this direction, and minus 16 nala kuda it will be experiencing in the same direction. Okay, so that is why we are actually changing the position. Yeah, when I'm just going for the change in position, what is happening? In the minus 16 nala, this will be experiencing an attractive force. Yeah, and the 6 microcoulomb vanda, it is actually a positive charge. Idu vanda negative tha. So this will be coming as a attractive force. And due to this plus 4, this will be again away from it. Yena adu vanda repulsive arukum. Purinjidada everybody? Understood, yes or no? Please let me know everybody. So appadina what we will be doing? In the k will be get cancelled. 10 to the power minus 6, 10 to the power minus 6 will be get cancelled, and we will be having this equation. Okay, so now it is your turn. You can just take the square root of it on both the sides, and you will be getting the answer. You will be getting the answer as 0.6 meter. Okay, 0.6 meter is coming as the answer. Yeah, done everybody? So in the madri questions vandena, first vanda you should mark the direction again and again. I'm telling you, first vanda in the direction you have to mark. Adukapparanda you have to go for the calculation substitution part. First step is always the direction. Okay. So next one we can just go for another question. Two small conducting sphere of equal radius gave charge plus 1 coulomb and minus 2 coulomb respectively, and placed at a distance d from each other experience force F1. If they are brought in contact and separated to the same distance, then they experience a force F2. What is going to be the force ratio F1 by F2? This is what we need to find. So understand the first line. And the first line la what is given now? Two small conducting spheres of equal radius. Okay. So this is the plus 1 Coulomb da. This is what minus 2. And they are separated by a distance d. That is not given. Okay. Let it be. Now what happened if they brought in contact? So just understand, two small conducting spheres of equal radius, which means that is identical. In the point note panniko, wherever you are writing this, you can just go for it. If mark it, if the spheres are identical, if the spheres are identical, once it is in contact, okay, so initially idhila 1 Coulomb charge da, idhila minus 2 Coulomb da. When it is coming to contact, okay, in the two charges in the two spheres I am keeping in contact na. Note panniko, if I am keeping in contact, what exactly happening? Charge flow will happen. Okay, charge flow will happen. Till what time? Okay, till what time? When the charge become Q1 plus Q2 divided by 2. So we initially 1 Coulomb irundirichu, inga minus 2 irundirichu, and now I am keeping it together. What will happen? Charge flow will happen. If the bodies are identical, and the point note panniko, identical illana in the next lecture potential discuss pannumbodhu we will be discussing about it. So right now when if the two bodies are identical in the after this contact, each body will attain the same charge. Okay, after contact what will happen? After contact this will gain equal charges on each of the sphere, equal charge on each of the sphere. Each of the sphere equal charge kadaikum. The charge oda value Q1 plus Q2 divided by 2 da. And in the Q1 negative the negative sign you have to mark. Q2 negative and the Q2 kuda you have to keep it as negative sign. So now the thing is like Q1 na endada 1 da, and here it is minus 2 divided by 2. So what is happening? Here we will be getting minus 1 by 2 as the charge on each of the sphere. So initial condition la what is happening? Charges 1 and minus 2 da, correct? 1 and minus 2. And after contact what happened in the second line la what they are mentioning? They are kept in contact. Adukappuram each and every sphere will attain same charge only if it is identical. Appadina each of the body will get Q1 plus Q2 divided by 2. So inga paakumbodhu 1 minus 2 divided by 2 da. So each of the body will be getting minus 1 by 2. Next what is happening? Now in the minus 1 by 2 keep at a contact. Keep at a distance d. Appadina what is the force order ratio? Okay, everybody understood? Can you just find it? Can you just find the ratio of the force? You can find F1 from here. You can find F2 from here. So what is going to be F1? What is going to be F1? It is nothing but K into 1 into 2 divided by d square, and here it will be K into 1 by 2 into 1 by 2 divided by d square. Anyway, and the d square cancel agapore. Now can you just, that is what I said Abanna, we will be dealing that in the potential. The charge flow will happen till the potential becomes same. Understood? So that we will be dealing in the next part. So don't worry about it. So now the thing is like identical na you can use this equation. If it is not identical na, we will be dealing in the other case, till the potential remains same, the charge flow will happen. During that time you will be, equate V1 is equal to V2. Understood everybody? Everybody understood, yes or no? Okay, so idha vanthu we should discuss over here. So next vanthu we have the pro batch launches there. So guys, you can do one thing, you can just attend that launch. Okay, that is going to be a very small session. Till the time we can take a small break as well. So on the break kapra we will be starting with the potential part. Will it be okay? Will it be okay? So you can just go for the pro batch launch. Quick, you can go for it. Once it is done, we can just come back. I hope it will be hardly for 10 to 15 minutes. So now it is 5:35. So let us just come back at 5:45. So see you guys. Attend there. Okay, I'll be here. If anybody is having any doubt or something, you can just stay back. Others can go. hi. Yes, guys, yes. So let us just continue. Okay. So nama batch launch anta still it is going on. Paravalada, we can just start. Otherwise, now we cannot finish the syllabus. Okay, ma'am inge irke Shahid. Yes, Jayanti. Yes. So if you guys are here now, give me a heart, please, quickly. Quickly, Manti, you can give me a heart if you guys are here. Quickly give me a heart, guys. Yes. Kashifa, right? Yes. Perfect. Yes. Okay. Class inge pochla. Okay, yeah, fine. So let us just continue. So right now we were talking about the electric field, the force and everything we have discussed. Now we are moving on to the potential. Second chapter we are going to start. Okay. So now the thing is like we should understand. Okay. I'm very much weak in it. Okay, the names ellame vanda I will forget immediately. And I think my memory is bit better, I guess so. Okay, so yeah, so ipa we are going for the potential part. So adukku munnadi I just give you some sort of one or two terms which will help you to understand the whole chapter. So idila vanda first thing is just observe here. Whenever I am talking about potential energy, what is this potential energy that you should know? Okay, so potential energy na the work done against any conservative force any conservative force is stored as the potential energy. In the potential energy term வந்து எப்பவுமே it will be associated with the it will be always associated with the conservative force. So இந்த chapterல வரும்போது conservative force என்ன ஆகும்? What is going to be the conservative force in this chapter? What is the conservative force? அது வந்து nothing but the electrostatic force. Okay, electrostatic force. So இப்போ வந்து if you are doing a work against electrostatic force na அதுதான் வந்து இந்த potential energy convert ஆக போறேன். Okay, yes da, we will quickly finish this. So இப்போ வந்து potential energy ஓட expression என்னன்னா k q1 q2 divided by r. So q1 q2 are two charges and r na அதோட distance of separation தான். அந்த q1 ல இருந்து q2 ல இருக்கிற distance of separation தான் இந்த r value. So k q1 q2 divided by r will give you the potential energy. Now the thing is like, let us say I'm just giving you a question. This we have already explained, right? Yeah. Okay, so now I'm just giving you equal charges with equal distance of separation. Let us say we have 10 such charges. புரிஞ்சுதாடா? 10 such charges இருக்கு. அந்த charges எல்லாமே வந்து all are separated equal. I mean in the equal distance of separation தான் இருக்கு. அப்படினா குயிக்கா வந்து we should know how many pairs, which means இப்போ வந்து 3 charges na q1 q2 q3. Okay va? So இந்த மாதிரி 3 charges இருந்துச்சுனா distance of separation also let us say equal da. அப்படினா I should find the total potential energy of the system. So இந்த potential energy na அது வந்து ஒரு scalar quantity da. So இப்போ வந்து ஏதாச்சும் chargeல if there is a negative sign in the potential energy la கூட you have to keep the negative sign. So அப்படினா total potential energy will be U12 plus U23 plus U31. Correct? The potential energy due to Q1 and Q2, potential energy due to Q2 and Q3, potential energy due to Q1 and Q3. அப்படினா இந்த individual potential energy சொல்லும்போது I can say Q1 Q2 divided by R தான். And இங்க பார்க்கும்போது Q2 Q3 divided by R da plus K Q3 Q1 divided by R da. As I mentioned, in any of the cases, if there is a negative sign, and the negative sign you have to keep it here. புரிஞ்சுதாடா? Very good Aparna. It is actually we will be finding the sum of it. So let us say இப்போ வந்து இந்த q1 q2 q3 எல்லாமே வந்து same na, how you will be finding it da? The potential energy வந்து it will be same as 3 times u1. ஏனா இந்த value எல்லாமே வந்து இந்த charges கூட equal இருந்துச்சுனா you can say 3 into k q square divided by r. So now the thing is like, as I mentioned, இப்போ வந்து right now we have 10 such charges. அப்படினா இந்த மாதிரி எவ்ளோ pairs இருக்கு we should know, right? So and the number of pairs if you need to find na, okay, number of pairs if you need to find na, you can use this equation n into n minus 1 divided by 2. So equal charges, equal distance, அப்படினா you have to find it the potential energy for any of the two charges into the number of pairs will be giving you the total potential energy. இது வந்து superposition, we cannot say that. Okay, superposition principle na enna vector sum illada. So இங்க வந்து பாக்கும்போது இது வந்து ஒரு scalar quantity தான். Okay, so இதுதான் வந்து right now let us say இங்க வந்து 3 charges தானா. So I'm just substituting 3 into 3 minus 1 divided by 2. So 3 into 2 by 2, you will be getting 3 such pairs, 1 2 3. So in the madri you can do it. Let us say 10 charges. Now what I can do, 10 into 10 minus 1 divided by 2 into the potential energy. இப்போ வந்து இந்த potential energy by each of the two charges வந்து equal இருந்துச்சுனா number of pairs if you found, you can just multiply with that. புரிஞ்சுதாடா everybody? Got it? Yes or no? Please give me a heart if you understood. Everybody please give me a heart. Okay, so now the next one is potential energy. புரிஞ்சிடுச்சுனா you should know what is potential. Okay, potential na very simple. Again it is also the work done da. ஆனா work done per unit charge. Potential energy na work done pakka and the work done da it is stored as the potential energy. Ana when I am talking about potential na adu kuda work done da ana per unit charge irukku. So which means in the potential vanda I can mark it as work done per unit charge. Anyway in the potential energy vanda we are doing against, correct? Adnala tha I am just marking as a negative sign. Okay, if I am writing in terms of potential energy na I can just write U by Q. Purinjidada? So this is what the important thing when I am talking about potential, that is nothing but minus work done per unit charge da, or otherwise I can write in terms of potential energy divided by unit charge. Marakama like panikoda, also subscribe the channel. So next we have studied about the electric field for different cases. And the madri in the potential kuda for different cases you should study. First one vanda simple da irukke, it is nothing but the what is it, for a point charge da, that is nothing but kq by r. Okay, so in the case in the electric field madri it is always depending upon one source charge only, it is not depending upon any test charge. Okay, kq by r, k na again 9 into 10 to the power 9 da, q na and the charge oda value, r na and the charge la irundha where you need to find the potential and the distance da that value. Next one the potential due to ring. So that is again kq divided by r square plus x square all raised to 1 by 2. So same values, same how we have found there, and the ring order value varaporadhu it is not sorry, and the ring order value varaporadhu it is nothing but the what is it, and the radius one the capital R, and the distance from the center to the point where you need to find the field on the axis, adu vandu x value da. So exactly the same ditto representations. Ana vandu when it comes to the potential, instead of there we have found it is nothing but kqx divided by r square plus x square all raised to 3 by 2. Instead of that here it will be kq divided by r square plus x square all raised to 1 by 2 it will come. Next one is nothing but obviously for the shell. Okay, so holosphere irukku, holosphere na adoda potential inside vanda it is going to be constant value throughout inside the point, yena field vanda zero da. Okay, for a holosphere field vanda zero da, so adanala I can say that field zero na potential vanda constant da irukum, which will be equal to the potential at the surface. So inside and surface vanda same value kq by capital R. Capital R na it is nothing but the what to say, the radius of the sphere da. Next on the outside varumbodhu it is kq by r, and the small r enna center la irundha, and the holosphere oda center la irundha the point where you need to find the field. Next one vanda solid sphere da, and the equation vanda it's little complicated. Kq divided by 2r cube into 3r square minus r square, again capital R vanda radius of the sphere da, small r is nothing but the distance from the center to the point where we are finding the field inside, sorry, the potential inside. Yes, understood everybody? Yes or no? Yes or no? And outside and surface vanda it is exactly same as the previous holosphere. Okay va? So in the points ellame vandu important da, and also to be specific in the syllabus illa this is not mentioned. Okay, aanalum in the risk vandu we, because yena vandu these are all related things, so adanala we cannot take a chance. Adanala I will recommend possible na in the equation you have to study. Idu vandu syllabus la mention pannala, but I hope you guys will be doing it. Okay, you can just study this along with the rest of the what is the equations, you can study this also. Okay, in which inside will be 0. No, inside it is not 0, field the 0. Okay, field the 0 inga varumbodhu adukku value irukku which will be equal to the at the surface. So next one we have done with all those things. Yes. Another important relation which you should study is E is equal to minus dV by dr, which means in the field is equal to the negative gradient of potential. E is equal to minus dV by dr, which means the field is equal to the negative gradient of potential. Next one, let us say in the potential we are getting like this. Okay, this is I cap, this is J cap. You can find it in a way that electric field will be minus, I am taking outside. So this will be dou V by dou X I cap plus dou by dou Y of V J cap plus dou by dou Z of V K cap. So in the madri, this is what we are calling partial differentiation. We will do anyway some problems, we will do it. So in the equation vandu purinjiko, here I have taken the negative sign outside. If you are keeping the negative sign inside, this will become minus dou V by dou X I cap minus dou V by dou Y J cap minus dou V by dou Z K cap. Purinjidada everybody? So those who have not liked the session till now, you can like. Also share max to max. I mean, like you can just share with all your friends. Done. Okay. So this is important another relation which you should study. Next is equipotential surface. That is again another important concept which is coming. Are you guys here? If you guys are here, give me a heart quickly. Give me a heart quickly, everybody. Everybody give me a heart quickly. If you guys were here. And also we are going to discuss current, electricity and semiconductors. Okay, so everyone should join on time. 4 o'clock we are going to start the session. I want everyone should attend from the beginning. So on the chapter over concept plus the questions, everything we will discuss. So adanala everyone should join on time 4 o'clock. Okay, thank you so much. So equipotential surface, and the name is same potential. And the surface any of the point will be having the same potential. So a few points you should remember, you should study. First one the work done shifting a charge in the equipotential surface. So this is let us say my equipotential surface. I am taking a charge from here to here, which means in the same surface I am taking. Now what will happen? And the potential order and the work done 0 agapore. Yena work done order expression Q into delta V. Correct? Q into, very good Arundus. Okay, so now delta V it is going to be VA minus VB, but in the value equipotential surface VA will be equal to VB, so work done will be coming as 0 if you are taking a charge in the same equipotential surface. Purinjidada everybody? Yes or no? Please quickly give me a reply. Next one is in the field lines and the equipotential surface. Note panniko, field lines and the equipotential surface will be always mutually perpendicular. Field lines and equipotential surface will be always perpendicular to each other. Next is again, in the two equipotential surface will never ever intersect, and also for a point charge in the equipotential surface the concentric spheres are. Okay, for a point charge in the equipotential surfaces so if I am taking any point over here, this what will happen? Adila the same potential. So if I am taking a charge from here to here, what will happen? Anga work done 0 agapore. Purinjidada? Everybody got it? Solid sphere oda inside point da. Understood? Okay. So now this is for a point charge. For a line charge it will be cylindrical in shape. Okay, for a line charge or linear source it will be cylindrical in nature. And last one if it is a plane sheet. Okay, if it is a plane sheet, this will be coming as some parallel planes adoda shape varapore. Everybody understood? Yes or no? Please let me know da. Everybody quickly tell me. Are you guys getting it? Yes or no? Yes. So this is in the equipotential surface important points. You guys have to study all these points. Yena statement based questions possibility irukku. Okay. So next again one more topic okay. So in the concept perfect புரிஞ்சிடுச்சுனா இதுல வரப்போற எல்லா questionsume you will be do it in a second. Okay. So just sigma, it is actually the surface charge density Q by A. Okay. So இப்போ listen carefully. We know inga I have a hollow sphere. Okay. Listen carefully da idu இன்னும் important ஆன concept. So we know that if let's say இதுக்கு Q1 charge இருக்கு இதோட radius R1 னா if I am taking a point A over here, what is the potential at A? What is the potential at A? Can you just let me know in the chat box? What is the potential at A? இது ஒரு hollow sphere da. அதனால definitely in the potential same as this surface இருக்கும். So this will be Q1 divided by R1. Correct? So now again I am having another sphere which is little bigger. புரிஞ்சுதாடா? So now இதோட radius R2, charge Q2. Okay, very good, it is constant. Yes, perfect. So இப்போ இந்த Q2 இருக்கு அதோட radius R2. So now I am just asking you in the point la irukra potential what is going to be VB? What is going to be VB? K Q2 divided by R2. Yena in the B point is actually coming inside the sphere. Inside the sphere na adoda potential as you mentioned constant arikum which will be equal to the surface. Now I am making it together. Careful paathuko. Okay. So idha nama first sphere. Adoda radius R1 and idoda charge Q1 and the larger sphere is having R2 as radius. Charge Q2 da. Now I am going to give you some points over here. Just focus over here. In the point A irukke. Here on the surface it is B. Here it is C and here it is D. Now my question is what is the potential at A? Okay, what is the potential at A? So if it is simply இப்போ on the small sphere இருந்துச்சுனா there is no much confusion ma'am, inside point simply you will be telling the answer. So right now the thing is like in the point A ல இருக்கிற potential due to two things இருக்கு. அந்த small sphere னால இருக்கும் plus the outer sphere னால இருக்கும். So I am just writing V1 plus V2. V1 enna the contribution due to the small sphere. So adu what is going to be V1? So that is nothing but inside point illada. So KQ1 divided by R1. Yena the point A is actually inside the small sphere. Now guys tell me what is going to be V2? Okay, and the bigger sphere nala what is the contribution of potential at this point A? Okay, and the bigger sphere. So on the bigger sphere paakumbodhu you can say that ma'am on the A point is actually inside the bigger sphere. Appadina for a bigger sphere the point is inside, so the potential will be coming as K Q2 divided by R2 which is nothing but due to the what to say in the inside point la irukra potential equal to the potential at the surface and we are getting it. Everybody understood? A is the inside. Amada, A is inside the small sphere as well as it is inside the bigger sphere also. Now I am going for this point B, VB. So in the VB la kuda due to the smaller sphere there is a contribution and due to the bigger sphere also there is a contribution. Now can you tell me guys, can you give me the answer for the potential, the total potential at the point B? What is going to be that? K Q1 divided by R1. Yena in the B point is actually on the surface of the sphere. Correct? Surface of the sphere. So now I can say KQ1 divided by R1. Now again considering the bigger sphere, இந்த point B எங்க இருக்கு? That is again inside the surface. Correct? That is again inside the surface. So I can say K Q2 divided by R2. புரிஞ்சிருச்சுனா give me a heart. Quickly give me a heart. Everybody quickly. Yes, of course I will drink. Thank you for reminding me. Okay. So next point வந்து I am going for VC. In the surface of the bigger sphere la irukke. Okay, surface of the bigger sphere la irukke. So now you guys have to tell me for the smaller sphere. Okay, just forget about the bigger one. இப்போ வந்து என்கிட்ட இருக்கிறது அந்த ஸ்மால் ஸ்பியர் தான். அந்த ஸ்மால் ஸ்பியரை ஃபோக்கஸ் பண்ணி பார்க்கும்போது where is actually the C point? Is it inside or at the surface or outside the smaller sphere? Can you give me the answer quickly? இந்த பாயிண்ட் C வந்து அந்த ஸ்மாலர் ஸ்பியரோட இன்சைடா இல்ல சர்ஃபஸா இல்ல அவுட்சைடாடா? Quickly give me the answer. Quickly everybody give me the answer. So அது வந்து actually outside point தான். கரெக்ட்டா? outside point na we know the potential oda value. What is the potential oda value? KQ divided by small r. What is small r? What is small r? Tell me what is small r, everybody. Yes, very good guys, it is outside. So tell me what is small r? It is nothing but in the case what is small r? What is small r, everybody? Very good, I can see the right answers. Yes, on the surface. Very good Abarna, it is actually R2. Appadina, can you just give me the contribution from the smaller sphere? What is going to be the potential due to smaller sphere? Can you give me the answer in the chat box? We know K into the charge on the smaller sphere divided by small r. In the case in the small r na, it is nothing but the distance from the center to the point where we need to find the potential, and that will be nothing but R2. புரிஞ்சுதாடா everybody understood? ஏனா இந்த distance வந்து R2 தான். இந்த கேஸ்ல small r வந்து R2 தான். புரிஞ்சுதாடா? Yes or no? Quickly tell me the answer. Very good, KQ1 divided by R2. Okay, now for the larger sphere, what is going to be the contribution da? What is going to be the contribution due to larger sphere? It is actually at the surface. Correct? So now I can say KQ2 divided by R2. Understood? Everybody tell me guys, yes or no? Are you guys getting it? So now quickly you should tell me what is VD. Okay, in the smaller sphere oda center la irundha in the point D la irukra distance vanda I am telling you small r da. Appadina tell me what is the total potential experienced at the point D. Total potential experienced at the point D. Quickly you can tell me. What is going to be that? So for the smaller sphere it is outside and the distance one the small r da. So KQ1 by r plus for the outer sphere or the smaller sphere, bigger sphere also, the point is outside. So that will also come as KQ2 divided by r. Everybody getting it? ஏனா வந்து இந்த மாதிரி questions வந்து usually they will be asking in the question paper. That is what in the concentric spheres இருக்கிற questions வந்து it is very important. You should know the concept. In the basic idea மட்டும் போதும். If you understood, give me fire. Give me a fire if you understood. Then we can move on to the next one. Very good. I can see the right answers. Very good. Aparna, Arun, Sasmita, right? Very good guys. Okay, so இதுதா வந்து what I have mentioned in the basic concept வந்து புரியணும். Okay, இதுல வந்து we didn't study anything new. What we have applied, we already know in the potential ஒரு hollow sphere இருந்துச்சுனா அதோட potential inside, outside and the surface ல என்ன ஆக போற we know it. அதுதா வந்து we have applied it. Okay, இதுல வந்து we are not studying anything new. ஆனா வந்து maybe question கேக்கும்போது we will feel little tensed. So இப்போ வந்து I'm just giving you. So we have 3 such concentric spheres. Okay, so now my question is, This is the point. This is the R1 charge Q1. This is the R2 charge the Q2. This is nothing but R3 charge the Q3. Point this is what A. So can you just tell me what is potential at A? Can you just tell me on the basis of the things which is given? Can you give me the answer quickly? What is the potential at A? This is the point A. Now you have to tell me what is the potential at A. So definitely considering the smaller sphere, the point A is actually outside. So K into Q1 divided by, what is the distance of separation? In the center, for the smaller sphere, the distance is coming as the R2. So I can go for KQ1 by R2. Next one, for the second sphere, K into Q2 divided by, adu vandu on the surface la irukke, so I can just keep it as R2 plus for this the outer sphere, the bigger sphere, it is actually inside, so I can say that KQ3 divided by R3. Purinjidada? Everybody got it? Yes or no? Yes or no? Quickly tell me da. So in the madri da we will be solving the questions which is coming regarding the, yes, of course we will go for the 11th as well. Okay, so this is how we should deal the potential for concentric spheres. This is very important. That is why I am giving more time for this. Okay, so this is done. Next one, the sharing of charge. We already discussed about it. So whenever, we have mentioned identical na, we know it will be Q1 plus Q2 divided by 2 da. Now in the two bodies identical illa. But we should know the charge order, how much charge it is stored. This is puriyanumna, and the case you should understand only few things. First one, the charge flow will happen till the potential remains same. Okay, and the potential same agara varaikkum in the charge flow will happen. Second thing is like the total charge okay, initially and the body like Q1 Q2 charge and in the contact kappuram the charge becomes Q1 and Q2, but this will be conserved. In the 2 points you can solve any such questions, any questions coming from sharing of charge. In the 2 points you can start. First one, the conservation of charge. Second one, in the charge flow will happen till the potential remains same. Okay, so potential remains same. Now what will happen da? K Q1 divided by R1, which is equal to K Q2 divided by R2. Next one is, you can just make sure in the Q1 in terms of illana Q2 in terms of capital Q1 and Q2. Everybody understood? Everybody understood? Yeah. Ipo visible ada? Ipo visible everybody? Is it now it is okay? Yeah. So in the case the potential, in the potential the same agara varaikkum charge flow will happen plus the charge conservation, which means initial charge oda sum should be equal to the final charge oda sum, which means Q1 plus Q2, capital Q1 plus Q2 na initially irukra total charge, small q1 and q2 na final on the two bodies la irukra charge da, and you can use this equation. Q2 will be equal to the total charge in the beginning, which means after also that's going to be same, Q1 plus Q2 into R2 divided by R1 plus R2. No need to study this equation by heart. You can use that expression which I have mentioned. So adila the Q1 and Q2 you will be writing the expression in terms of this Q1 plus Q2. So Q2 will be Q1 plus Q2 into R2 divided by R1 plus R2. If you need to find Q1 you can use Q1 plus Q2. Instead of R2 you can go for R1 divided by R1 plus R2. If you are feeling like I will take a lot of time for derivation and everything, I will suggest you people to by heart this equation. Total charge divided by total radius, or let's say sum of the radius, into R2 for Q2. Okay, for Q1 it will be into the radius of the first sphere. Okay, so idha vantha we should find in this. Next vantha we have the dipole. So let us go for the dipole. Adukapre we can again go for a question practice. Okay. One second. Okay, so now we are going for the electric dipole. So what is no Durezing actually ivanga ellame selfish ada irukke, so no need to tell, they won't do it, they are not ready to appreciate people's effort, that's the thing, so forget about it. Okay, let us just study. So now electric dipole da, in the electric dipole na enna, two charges, okay, equal and opposite, இந்த charges equal ஆ இருக்கணும், opposite in polarity ஆ இருக்கணும், separated by a very small distance, அதுதான் electric dipole. Okay, electric dipole na என்னடா, two charges separated by a two equal and opposite charges separated by a very small distance is known as the electric dipole. And on the electric dipole ku you should study what is dipole moment. Okay, dipole moment na enna, P is equal to Q into the distance of separation. Okay, so don't study Q into 2a. Why we are doing that? Because we are doing some derivations in those cases. Adanalata we are actually multiplying it with 2a. Okay, 2a nalum what is the meaning? அது distance of separation தான். அந்த கேஸ்ல இந்த a னா சென்டர்ல இருந்து இந்த சார்ஜ் வரைக்கும் இருக்கிற distance தான். So for a safety side you can study this equation. Dipole moment will be equal to charge into distance of separation. Understood? Charge into distance of separation. எப்பவுமே இந்த dipole moment it is actually a vector quantity. அதோட direction negative to positive தான். Okay, negative to positive தான். And next important ஆன few relations இருக்கு. Electric field due to dipole at any point. Okay, dipole due to any point Kp by r cube. Okay, Kp by r cube into root of 1 plus 3 cos square theta. So இப்போ axial line la if you need to find na theta 0 ஆகும். If you need to find at the equatorial line theta 90 degree ஆகும். So you can just study this equation. இது general equation da. If you know this you can use it any cases you can go for it. So net electric field will be Kp by r cube root of 3 cos square theta plus 1. When it comes to potential it will be Kp cos theta divided by r square. புரிஞ்சுதாடா? Very good Arun Prasad, it will be Coulomb meter தான் அதோட யூனிட் வரப்போறேன். Okay, so next இந்த relation கூட you should study in the tan alpha and tan theta relation. இந்த theta என்னன்னா let us say இதுதான் நம்ம dipole. So இங்க வரப்போறது நம்ம minus q, here we have the plus q. So இந்த பாயிண்ட்ல தான் we need to find the field. So in the centerல இருந்து you will draw a line which will be the position vector and the dipole will make an angle theta with each other. And definitely we can say that. So inga varumbodhu we will be having the electric field like this. So the net electric field will make an angle alpha with the position vector or same direction, like it will be making an angle alpha. So now the relation comes tan alpha will be equal to tan theta by 2. Okay, dipole field order expression is it not visible? Kp by r cube root of 1 plus 3 cos square theta, 3 cos square theta, and idu Kp cos theta divided by r square. Done? Everybody understood, yes or no? So idha vandu the expression we have in the relation kuda you should study. Yeah, multiple times in the concept vandu they have asked, but during that time the students were struggling to do the derivation and come to the final result. Ana vandu we don't have much time, we can just directly study this. That is electric field, net electric field. This is the net, what is it, the potential. So இப்போ வந்து axial line na what will happen, we can just go for axial. When it is coming as axial line, theta will be 0 degree, and for equatorial line theta will be 90 degree. You can just observe this diagram. Okay, so when it is at the axial point, what will happen in the position vector vandu ippadi da varapore. So theta will be coming as 0. When it is at the equatorial point, what will happen, this will be making 90 degree with the dipole. Everybody got it, yes or no? Quick give me a response da. If you understood na, quickly give me a response. Everybody done and dusted. Perfect. So next on the capacitance da, adukapram we can quickly go for solving some questions till 7. Okay, adukapram we can go for the gravitation chapter. Okay, gravitation chapter la advantage enna, as I mentioned, half of the chapter vandu we are not studying, we will compare from electrostatics and we will learn. Okay, adukku vandu extra effort edum we are not putting. Modern physics vandu already did puja, already we have done it. Okay, நாளைக்கு வந்து semiconductor இருக்கு plus current electricity sharp at 4. So next வந்து capacitance தான். So in the capacitance க்கு வந்து we have to study we have to understand one concept. The charge, okay, the charge stored in a capacitor will be directly proportional to V. So Q will be equal to CV. C na adu vandu capacitance, adu vandu or constant value. Okay, and the C oda what is a unit vandu farad da. Okay, next vandu usually we will say we need two conductors for the capacitor. Ana vandu even with one spherical capacitor we can create, or let's say we can say we can create a capacitor. So adakaga we are assuming one is here, okay, one sphere is here with a radius r, another one I am assuming that it is at infinity. Okay, so adha vandu what I have written over here, isolated spherical capacitor. Usually we need two plates, or let's say two conductors. Ana vandu even using one also we can make a capacitor, and the capacitance vandu for an isolated spherical capacitor vandu 4 pi epsilon naught r da. Okay, 4 pi epsilon naught r da. Next வந்து energy stored in a capacitor, அதோட equations வந்து important தான், derivations எதுவும் தேவையில்லை. So q square by 2z, or which is also equal to, you can give substitution for q, you can give substitution for c, and you will be getting three different equations. Q square by 2z which is equal to half cv square which is equal to half qv. Depending upon the question you can choose the equation. Next one is, we know that we have different types of capacitors. Adula vandu major ah irukkiradhu vandu parallel plate capacitor. So in the parallel plate capacitor it is not necessary that the plate vandu square shape ah irukanum. Okay, spherical na simple da, in the spherical shape la oru conductor irukum, adukapram concentric ah another sphere irukum. Okay, so on the second sphere illama kuda we can create a capacitor. Adudha vandu isolated spherical capacitor. Okay, so idoda vandu center vandu concentric ah irukum, center vandu same. Parallel plate na actually vandu we have two plates, we will keep it parallel. It is not necessary that in the plate or a shape on the usually plate in the solumbodhu we will be having what to say in the rectangular shape illana square ah irukano, appadi edhu illada, any random shape you can choose, ana vandu idu parallel ah irukano. Okay, adha vandu parallel plate capacitor. Okay, adha vandu major ah vandu we need to study in this chapter. And the parallel plate capacitor oda capacitance vandu it is coming as a epsilon naught divided by d da. Okay, yeah, parallel plate capacitor, அதோட capacitance வந்து A epsilon naught by D தான். இப்போ வந்து இந்த two plates குள்ள இருக்கிற medium வந்து different இருக்கு. Okay, இந்த medium வந்து different இருக்குனா I can replace this equation as A epsilon naught K, or let's say relative permittivity divided by D. D na the distance of separation da, area na in the plate oda area da. புரிஞ்சுதாடா? So capacitance will change depending upon the medium, depending upon the shape, depending upon the the charge stored, ellame this is depending. Okay, and the force between, okay, in the plate nala in the plate it will be experiencing some force, correct? So inga vanda there will be a charge, here the opposite charge will be there. Appadina this will exert a force on this will exert a force on this, and the force oda value வந்து q square divided by 2a epsilon naught. Okay, q square divided by 2a epsilon naught. In the values equations ellame வந்து important, please note it down. And also if I am asking you what is the total charge on a capacitor, can you give me the answer? What is the total charge on a capacitor? Please tell me what is the total charge on a capacitor. Total charge on a capacitor will be, quickly you can tell me, everybody. What is the total charge on a capacitor? அது வந்து எப்பவுமே the net charge வந்து எப்பவுமே 0 ஆக போறே. ஏனா one plate ல plus q னா another plate ல இருக்க போறது minus q தான். So total வரும்போது it will be always coming as 0. Important point note பண்ணிக்கோ. Okay, so the total charge on a capacitor வந்து 0 தான். ஏனா one plate ல plus q தான், another plate ல it will be coming as minus q தான். Okay, and also let us say இப்போ வந்து we have mentioned இந்த மாதிரி தான் இந்த capacitor இருக்கு. இங்க வந்து I have made a medium in between. அப்படினா இந்த capacitance will be coming as K times the capacitance in air. Okay, or otherwise I can go for A epsilon naught K divided by D தான் வரப்போறேன். So இப்போ வந்து I'm just not filling completely. Okay, I'm not filling it completely, and the dielectric medium vanda I will be keep it for a small distance. I'm taking this thickness as t. Total distance of separation vanda it is coming as d. Appadina and the capacitance oda expression vanda A epsilon naught divided by D minus T plus T by K, and the expression kuda important da, it is very important. Next one vanda we know that whenever we are connecting it with a battery, okay, whenever we are connecting it with a battery, definitely what will happen, we are providing the constant potential, correct? We are providing the constant potential, so definitely the charge will come, the charge will be stored here, this will be plus q, this will be minus q. So now I can say that the work done by the battery will be the charge into the potential. This is the expression we have studied. The work done will be the charge into the potential. Work done will be charge into potential. We already understood the charge. Okay, the energy stored in the capacitor it is nothing but half into QV, which means half of the work done by the battery is actually stored as the energy. Where is the other half, guys? Where is the other half? Can you give me the answer? Where is the other half? The total work done was the QV da. Okay, total work done was the QV da. E will be equal to the energy stored was the half QV, which means idoda half value da. Appadina half of the value is actually lost as the heat. Okay, so work done by the battery is utilized for two purposes. One is to store the energy. Yes, very good Arun, it is actually lost due to the heat. So this is the important few relations. Next one in the capacitance, we are in the capacitor, we are connecting in series na adoda effective varaporadhu 1 by Cs, which is equal to 1 by C1 plus 1 by C2 etc. If it is parallel na it will be C1 plus C2 plus C2 C3 etc. Idu just ulta as the resistor. resistors connect பண்ணும்போது சீரிஸ்ல இருக்கும்போது தான் R1 plus R2 plus R3. ஆனா இங்க capacitance சீரிஸ்ல connect பண்ணும்போது it will be coming as 1 by C1 plus 1 by C2 plus 1 by C3. And when it comes to parallel, this will be C1 plus C2 plus etc. இங்க வந்து if it is identical, okay, if it is identical, the capacitance will be coming as C by N. In the case identical na, this will be coming as N times C. Understood? Now quickly give me a fire, da everybody quickly give me a fire if you understood. One more topic da in the capacitance la irukke. One after that we are free. We are going for solving some questions and quickly we are going for gravitation. N means na the number of capacitors. Ipo vanda identical 10 capacitors irukku, adu vanda identical ah irukke. Parallelly we are connecting na 10 into capacitance value. புரிஞ்சுதாடா? Okay, yes. So next வந்து dielectrics தான். இது கூட இம்பார்ட்டன்டான ஒரு கான்செப்ட் தான். What is this dielectric? Dielectrics na it is actually insulators தான். Okay, so usually வந்து இந்த insulators and dielectrics க்கு வந்து same meaning தான் இருக்கு. ஆனாலும் definitely whenever we are giving new name na அதுக்கு வந்து கொஞ்சம் what to say speciality இருக்கும்லடா. So அந்த மாதிரி இந்த dielectric and insulator, to segregate this we will say இப்போ வந்து எனக்கு வந்து ஒரு இன்சுலேட்டர் இருக்கு, ஒரு dielectric இருக்கு. So இப்போ வந்து இந்த இன்சுலேட்டரை I am just placing in the field, electric field. இந்த dielectric I am placing in the field. Okay, அப்படினா this dielectric will go for polarization. ஆனா இது வந்து it won't go for polarization. Understood everybody? So what I said, when I am talking about dielectric, when I am introducing this to the electric field, okay, whenever I am introducing into the electric field, it will be get polarized. Very good, Aaron. Okay, it will be get polarized. So அப்படினா we should know what is polar and non-polar molecule. Polar na even in the absence of electric field, okay, even in the absence of electric field, it will have some dipole moment. Okay, it will be having some dipole moment, which means in the negative and positive, dipole na enada oru negative and positive equal and opposite charge da, correct ah? So in the centers vanda they will be little bit separated, which means anga oru dipole moment irukku. Ana when it comes to non-polar, okay, when it comes to non-polar, what will happen? Yes, in the plus and minus one, the overlap, it will be like this, which means on the distance of separation between the charges one the zero. Appadina tell me da, what is the dipole moment? Tell me. What I said, whenever I have a non-polar molecule, in the positive and negative one the it will be overlapped each other. அப்படினா இந்த distance of separation between the two charges வந்து 0 தான். அப்படினா dipole moment ஓட value, what is going to be the dipole moment ஓட value? What is the dipole moment ஓட value? Tell me quickly. What is going to be the value? And the dipole moment ஓட value என்னடா? It will be coming as 0. ஏனா dipole moment na charge into distance of separation தான். கரெக்டா? அப்படினா இந்த கேஸ்ல distance of separation 0 na dipole moment ஓட very good, dipole moment கூட it will be coming as 0. அப்படினா non polar na in the absence of electric field அதோட dipole moment வந்து 0. ஆனா polar na அதுக்கு வந்து ஒரு dipole moment இருக்கும். Okay, next வந்து அதோட examples. And right now in the polar non polar molecules வந்து if I am introducing, இது வந்து ஒரு crystal இருக்கு, let us say இதுதான் வந்து ஒரு crystal. Okay, இதுல வந்து I am giving electric field in this direction, which means external electric field. What will happen inside? அதுதான் வந்து we should know. So actually வந்து if electric field is going like this, இது வந்து positive side, this is coming as negative. அப்படினா இங்க வரும்போது we will be having negative positive, here also we will be having negative positive, like this way it will come. So now you can see that the field lines will be coming like this. So we know whenever I am talking about a crystal, இது வந்து closely packed தான். So actually வந்து எனக்கு வந்து இவ்ளோ separation தெரியாது. Usually when I'm looking at this crystal, I can see that this is, okay, in the field actually straightly coming from positive to negative. Which means inside the material there is a field induced. Okay, and that is though in the opposite direction of external field. Understood? Understood? Everybody got it? Yes or no? Please let me know. Da. So what I said, whenever we are introducing this polar or non-polar, when we are introducing this to the electric field, there will be an induced field inside, which will be actually opposite in the direction of external electric field. Purinjadada? Very simple. Whenever we are introducing this dielectric material in the field kulla, we are placing it. Appadina opposite direction there will be a field induced. Opposite direction external field or opposite direction we are getting a field. So which means the net field will become the external minus the induced. Okay, wow. External minus the induced, and also you should know the induced charge. Okay, other expression koda you should know, that is nothing but Q into 1 minus 1 by K, and the induced charge order expression koda you should learn. Purinjichira? Yes or no? Both polar and non-polar become polarized, which means it will also produce dipole moment whenever we are introducing into the electric field. Okay, so idha we should know in the chapter capacitance. Now let us quickly move on to the question part. Okay, so we did few questions and now we are moving on to the another segment of questions. So quickly, are you guys ready? Ready na? Give me a fire, everybody. Ready na? Give me a fire. Quick, we should go for the gravity. And this one is plus, this one is minus. That is why I kept a minus sign. Divided by the distance of separation is r. Okay. Next one in the pair. So plus k q square divided by r. And inga kuda oru pair irukku, minus k q square divided by r. Next one diagonally we have another 2. So let us say in the oru pair irukke, which will be coming as k q square divided by, in the distance we should know what is going to be that distance. What is going to be that distance? This r, this is also coming as r. So this distance will be coming as, can you give me the answer? In the distance, in the minus q and plus q is separated with the distance, that is nothing but root 2r. Exactly the similar way, here we have another pair which is coming as again minus k q square, distance of separation will be same, so that will be root 2r again. Very good, very good. So now what will happen now? Kq square minus kq square gone, plus minus gone. So right now we will be having minus 2 kq square divided by root 2r. So this will become again root 2 kq square divided by r. Everybody understood? Yes or no? Please let me know quickly. Quickly let me know in the chat box. Oh my god, this is not working. Oh my god. Okay, done. Now let us go for the another question. What is the charge on inner sphere after switch S is closed? What is going to be the charge? Okay, so they have given us X. So first what should I know? I need to know the net potential at the surface of the inner sphere. First we need to understand. Concentric spheres part we have already studied, correct? So now you guys have to tell me what is going to be the potential at the surface. Let me just call it as point A. What is the potential at point A? It is nothing but due to the inner sphere, so which means K into the charge in the inner sphere is X divided by the radius is r. Next this outer sphere will also contribute here. Appadina again k into charge capital Q divided by in the what is in the bigger charge in the point is actually inside, correct? Appadina this will be actually equal to the charge at the surface. Okay, now the thing is like it is connected. Okay, it is connected, it is earthing is done. Earthing is done na and the body ke illana and the sphere ku it will get the potential same as the earth. What is the potential of earth? Can you give me the answer? What is the potential at earth? What is the potential of earth? Quickly give me the answer. எப்பவுமே earth zero potential la da irukka pore. So now you can equate it with 0. Okay, now it is your turn. You can find what is going to be the x value. Very good, very good, very good. Quickly you can give me the answer. What will happen? K x by r, which will be equal to minus k q divided by 2r. R gone, k gone. So what will be x? X will be coming as minus q by 2. Next question. Find the dipole moment. Okay, we need to find the dipole moment in this case. What is happening here? So now look at the figure. Inga varumbodhu we have the plus q. Very good Arun. Okay, inga varumbodhu plus q irukke, inga minus 3q da irukke. So now I can just make sure idu plus q na. To get a dipole we need a equal and opposite charge. So inga plus q na, I can say that inga in the minus q la irundha I am just taking minus 3q la irundha I am taking minus q. So appadina what here after this we have minus 2q. In the minus 3q larunda already we have minus q. We made a pair. Okay, we made a two equal and opposite pair. Okay, so ipo what left here minus 2q da inga paakumbodhu plus 4q irukku. So to create another dipole, okay, inga we got the charge as minus 2q na on the side la what must be the charge to get a dipole? Equal and opposite charge irukkanum. So inga varumbodhu minus 2q na equal and opposite plus 2q da, the direction ippadi da irukum. Okay va? So in the plus 4q la irundhu already I have taken plus 2q. Inga minus 2q da irukke. So inga irukra plus 2q, inga irukra minus 2q will make another pair. So that is again from negative to positive. Okay, so inga already we have taken plus q, inga minus 2q also we have taken. So ipo if I am writing p is equal to q into the distance of separation is a, so p is equal to qa. Okay, appadina tell me in the case what is going to be the dipole moment, which means what is p dash here? Charge 2q da, distance of separation what is a da, correct? So appadina I can just write qa na p da, so p dash 2p. Here also we will be getting 2p. Till this everybody understood, yes or no? Please let me know. So now the thing is like in the dipole na vectors da, so I am just marking as vectors. So listen here, so minus q to plus q downwards, so that is what p. Okay, and in the side la in the minus 2q plus q, so that is what 2p. And here again minus 2 to plus 2, so that is again coming as 2p. Okay, So now two vectors are here. It is actually opposite in nature. Appadina I can say 2p minus p. So upward I will be having p. Here I have 2p. So now again you can do it as a vector. Okay. So two vectors irukku that is mutually perpendicular na. Adoda resultant will be root of p square plus 4p square, which will be root of 5p square, which means root 5 into QA it will come. Okay, QA it will come. So already I got the answers in the chat box. Very good. So this will be coming as option D. Understood everybody? So now let us move on to the another question. Okay, so an electric dipole with dipole moment 4 into 10 to the power minus 9 Coulomb meter is aligned at 30 degree in the direction of uniform electric field of magnitude 5 into 10 to the power 4. Calculate the magnitude of the torque. Okay, so what is the value of torque? It is nothing but P cross E. Illana we can say PE sin theta. Magnitude one the PE sin theta. So torque we can say in the dipole moment is straightly given 4 into 10 to the power minus 9. E value is 5 into 10 to the power 4 into sin 30, which will be coming as 1 by 2. Very good, very good. Quick you guys have given the answer. Option C it will come. Okay, option C the varapore. Okay, so idu 20 into 10 to the power minus 5 into 1 by 2. Okay, so 10 into 10 to the power minus 5, which means 1 into 10 to the power minus 4 Newton meter. So maybe calculation error arko. Okay, va? So now let us move on to some more questions. 2 point charges Q1 is here. Okay. Q1 is here, Q2 is here, okay, and Q1 is 2 Coulomb, and here Q2 is 1 Coulomb, and B is actually 1 centimeter. This is original 1 centimeter. This one is nothing but 2 centimeter. Now the thing is like, from the origin on the y and x axis, the electric field vector at the point P. So, inge irukira electric field da we need to find, which is actually making an angle theta with the horizontal illana x axis, and the theta da we need to find. In terms of tan theta we can find it. Okay, break okay, let us just think about it, because yena in the 8 o'clock vara mattunda I can just take the session. Yena in the studio is actually belongs to somebody else, so they will come at 8, so before that I have to leave. Okay, so now I don't think there is a point of break. Okay, Pooja. So now the thing is like, we should find the electric field. First one in the question lab we can just calculate, or we can just mark the direction. So ipo vande inga oru 2 Coulomb irukku. I wanted to find the field at this point due to 2 Coulomb. So what I will do, I will place a test charge. Okay, I will place a test charge. So inga irukkiradhu Q1 test charge na adu kuda positive da. So definitely this will be like this. In the electric field due to Q1 will be coming as like this. Next vanda in the 1 Coulomb irukku. Okay, in the 1 Coulomb nala this will also experience a force like this. Okay, this will also experience a field like this. So this will be coming as what? E2. Okay, due to this 1 Coulomb. So definitely 2 vectors irukku. So adoda vector sum da we need to find it. So idha vanda in the net field oda direction vanda ippadi da irukum. So now the question is, we need to find this angle. So adukkaga options paakumbodhu they have given in terms of tan. So tan theta na opposite side, which means E2 divided by E1. Now what is E2? What is E2? Tell me guys, what is E2? What is coming as E2? It is nothing but K into charge na 2 Coulomb da divided by the distance. This distance is coming as 2 centimeter. So I'll be writing it as 4 into 10 to the power minus 4. Yena in the distance one the 2 the r square it will be coming as 4 into 10 to the power minus 4 divided by, okay, divided by E1 the we need to find, sorry I have made a mistake. E2 the first we need to find, correct? So K into this charge will be 1 Coulomb and this distance is 1 into 10 to the power minus 4 divided by E1, which means K into 2 divided by 4 into 10 to the power minus 4. So K gone. So what else we have? 4 into 10 to the power minus 4 divided by 2 into 10 to the power minus 4. We will be getting tan theta as actually. So we can say that in the answer one the option D. Purinjidada, yes or no? Yes or no? Simple da irukke, calculation kuda avlo simple da. Tan theta na opposite side inga varumbodhu E2 da divided by E1. Okay, so now the thing is like we will be putting the value because we know the field due to point charges kq by r square da. So inga varumbodhu in the E1 value na k into the charge vanda 2 da divided by distance of separation idu da. So 2 into 10 to the power minus 2 the whole square. In the madri we will be finding E2 as well. Purinjidada everybody, yes or no? Yes or no? Please let me know. Quickly you can tell me. Okay, next question. A charged particle of mass m and charge q is released from rest na I am straightly writing u is equal to 0. Initial velocity vanda 0 da. Okay, so now what happened? Mass is given, field is given. Okay, mass is given, charge is given, E is given, and we can just neglect G value. The gravity one you can ignore. What is the kinetic energy of the charged particle after t seconds? Okay, so kinetic energy na adoda value vanda half m v square. And now the thing is like we know half m, so adu vanda it is given. V square da we need it. So on the V square they have given mass is given, charge is given, E is given, time is given, U is given. We need to find V. Appadina, which equation of motion we can use for this question? Can you please let me know which equation of motion we can use it here? Everybody quickly tell me da. Which equation of motion we can use it from here? We can go for V is equal to U plus AT. So V will be equal to 0 plus acceleration na MA. This will be experiencing QE. So acceleration will be QE divided by M. So QE divided by M into T. Next also we can substitute over here half into m into q square e square t square divided by m square. If anything needs to cancel, you can cancel and you can go for the right answer from the options. Very good. First law, the first equation, not first law. The first equation that we will be going for it. Very good, very good, very good, superb. Very good. So the answer will be option B, the, okay. So the potential inside a charged hollow sphere is, potential inside a charged hollow sphere will be, quicker you can give me an answer. Quickly give me an answer. And marakama like pannikoda everybody. Marakama like panniko, share panniko, also subscribe the channel because you are going to get a lot of good quality content for physics, chemistry and biology. NEET 2026 will be safe on your hands if you are following us. So adanala I am telling you, subscribe the channel. Marakama, don't say 0. Don't say 0. 0 illada. Okay, hollow sphere illaya. Field da 0. Potential da they have asked. So that will be same as that of the surface. So you know lots of questions actually I have added here. Ana vanda right now we don't have the option to do it. Yena gravitation vanda we need to start, right? Okay, analum over question order solution vanda I have already given in this itself. So ipo vanda you can just go for it after the class. You can go for it, no worries on it. So now Kyukka vantu we can do some 3-4 questions or questions of the capacitance. The capacitance of a parallel plate capacitor is 12 microfarad. The distance between them is doubled. Area is halved. Then what is the new capacitance? Again very simple question. What is the thing? We know capacitance which is equal to A epsilon naught divided by D. The new capacitance will be what they have done. Area is halved. So which means A by 2. Medium is not changed. But D, what is happening? The distance made it into 2. So we will be getting A epsilon naught divided by D into 1 by 4. So which means C by 4 it will come. So C it is already given 12 microfarad divided by 4 will give you the answer as 3. Understood everybody? Everybody understood? Yes or no? Quicker you can tell me. Are you guys here? Here na give me a fire. Da quickly give me a fire. If you guys are here, give me a fire. Yes, option D. Very good, very good, very good. So next one, the capacitance of a metallic sphere is 1 microfarad if its radius is nearly. So capacitance of a metallic sphere. So which means C is given as 1 microfarad and the capacitance will be 4 pi epsilon naught R. So now the question is what is this R value, which means C divided by 4 pi epsilon naught will give you the R value. So C is 1 microfarad divided by 1 by 4 pi epsilon naught. Yeah. So that will be coming as 9 into 10 to the power 9, which will be giving you the R value. Okay. Yes, very good, very good, very good. So now it is your turn. You can find the answer for me. Microfarad na 10 to the power minus 6 it will come. So guys, after the session, whatever be the questions which I added on the slides, please do it. Otherwise na question practice illama we cannot just we cannot crack good score. Very good. It will be coming as option A, 9 kilometers. Okay. So now another question, two parallel plates of area A separated by two different dielectrics as shown in the figure. The net capacitance is, we need to find the net capacitance. Okay, wow. So that is what we need to find. How we will be finding it? So we know that if this is the case, I can just connect, okay, I can just find this C1. Okay, so in the madri two capacitors irukku, okay, in the madri two capacitors irukku. So you can find C1 and C2, then you can just find the in the net capacitance one that you can find it. Yes, of course, 5 minutes break one I will definitely give you. Okay, so find C1. What is going to be C1? A epsilon naught K1 divided by D. So, idhula A area epsilon naught K1 is actually 1 divided by D is actually D by 2. So, I will be getting this. Next one is C2. C2 will be coming as A into epsilon naught K2 value is 2 divided by D by 2. So, this will be coming as 4. So, I will be getting 4A epsilon naught divided by D. Next one, what is the process? So, this is series connect pannittu. So, 1 by Cs which is equal to 1 by C1 plus 1 by C2. So, what you will be getting? 1 by Cs will be coming as D divided by 4A epsilon naught plus D divided by 2A epsilon naught. So, now you can find it. So in 1 hour la we will finish the gravitation vandu. As I mentioned, gravitation la half of the chapter vandu we are not going to study. In the chapter I compare panni I have made a PPT. So you can just look at that and you can just skip a lot of things. Okay. So now tell me in the question or answer, what is going to be the answer? Yes, yes. So everybody is saying option B lada A da varapore. Okay. Yes, very good Arun, very good, very good, very good. So now we are moving on to the another question. So the one the easy another question da. I'm not doing it. Okay. So now inga vandu we have a circuit. What is the net capacitance across AB? Idu da vandu question. Okay va? So how we will be doing it? How we will be doing it? We know that this C are in series. Correct? So adoda equivalent vandu C by 2 as we discussed. If it is identical, we can say this will be equal to C by N da. So anga vandu two capacitors irukku, identical da. So C by 2 da it will come. And here also the same thing will happen, C by 2. So now you can see that. So here we have C by 2. Here we have C. Here we have again C by 2. Okay. So idu da vandu the construction right now. So now the thing is like C by 2 is in parallel. Correct? Is it parallel? So identical da. So CP will be N times C da. So now 2 into C by 2 will be coming as C. And that C is again parallel to this C. So we can say that C plus C, which will be coming as 2C. Very good, very good, very good. Hence option A is the right answer. So next question, 4 plates of the same area of cross section are joined as shown in the figure. The distance between the plates is D. The equivalent capacity across A and B will be. So in the question I'm just going to give numbers. Idu vantha I'm giving it as 1. Okay. And this one is actually in the plate vantha actually it is shared with 2. So which means in the second plate vantha one side is shared with 1. Another one is shared with 3. Exactly the same thing is happening with the third plate as well. This is also shared with 2 as well as 4. So இப்போ வந்து 4 plates இருந்துச்சுனா we will be getting 3 capacitors. புரிஞ்சுதாடா? 4 plates இருந்தா 3 capacitors, 5 plates இருந்தா 4 capacitors, 10 plates இருந்தா 9 capacitors we will get. And அதுல வந்து இப்போ வந்து இந்த கேஸ்ல 2 plates வந்து it is actually sharing between 2 different capacitors. Now look at the figure. I'm just looking at this is what the terminal A. Okay, so in the terminal A ilirundhu we have this 1 as well as we have this 3. Correct? We have this 3 as well as 1. So in the 1 order, one side la we will be getting 2. Okay, and we can just say that in the 3 la one more 3 irukano. Okay, so this is nothing but 2. Next one பார்க்கும்போது இந்த 3ல இந்த 4 கூட it is actually connected. Okay, now the thing is like which one is left? We have one more 2 over here. So this is what the structure. We will be getting 3 parallel capacitors. இந்த மாதிரி questions வந்தனா first வந்து you should give the numbers. Okay, adula வந்து few plates வந்து they will share with different capacitors. So இப்போ வந்து இந்த plate பார்க்கும்போது one side is shared with 1, another one is shared with 3. Okay, so in the third plate பார்க்கும்போது this is also shared with 2 and the other side is actually shared with 4. Next வந்து இதோட terminals தான் பார்க்கணும். Okay, so when I'm looking at here this 1 and 3. Okay, so 1 is shared with only 1, 3 definitely shared with 2. So adanaala tha I'm just giving this terminals to the point A. Ena 3 வந்து it is actually shared 2 times for different capacitors. Exactly the similar way in the 2 வந்து I have to mark 2 times and 4 வந்து single time. So in the 3 வந்து is actually coming as parallel. Okay, so if it is parallel now, we know that this is nothing but the first one will be giving you A epsilon naught divided by D. இதெல்லாமே வந்து identical தான். So வந்து parallel இல்லையா, so அதனால NC, so 3 into A epsilon naught divided by D. புரிஞ்சுதாடா everybody? Yes or no? Yes or no? Give me a fire if you understood. So now the thing is like we are going for the gravitation. அதுக்கு முன்னாடி ஒரு 5 minutes break வந்து we need it. Okay, we need the 5 minutes of break. So let us go for a quick 5 minutes break. Okay, so let us just come by what time da? At what time we need to come back? Everybody tell me. At what time we need to come back? Okay, 5 minutes la we can just come back. Okay, Vada? So see you. Yes, 18, fine. 7:20. Okay, 7:20 ki we can just meet again. Okay, everyone should come. Okay. Thank you guys, thank you. After by 7:20 everyone should be here. Okay. So let us continue. Are you guys here? ஆரம்பிக்கலாமா? Okay. So where were you, Damodara? You cheated me. You didn't attend the first half. Not first half. We are almost done. Hardly 40 minutes la we need to finish the class. Okay? நமக்கு இதுனா break இருக்கு. Break-க்கு. புரியலடா? Not to me, I guess so. Okay, so now the thing is like we are going for the gravitation. Okay, so we are first going for the comparison. Whatever we have studied there, we will be just make some a replica in the gravitation chapter as well. Okay, wow. So right now, okay, yeah. So right now you can see the Coulomb's law. Okay, Coulomb's law la what we have mentioned k q1 q2 divided by r square. அங்க வரும்போது சார்ஜ்னா இங்க வரும்போது மாஸ் தான் வர போறேன். Okay, so electrostaticsல we have the charge. இங்க வரும்போது மாஸ் தான் இருக்க போறேன். And also அங்க வரும்போது கான்ஸ்டன்ட் ஓட வேல்யூ 1/4 pi epsilon naught. ஆனா இங்க வரும்போது g. Okay, 6.67 into 10 to the power minus 11. இதுதான் g value, the constant value. Okay, so next the force which is experienced by a unit charge. இல்லனா இந்த ஒரு charge experience பண்ற force due to electric field q into e தான். Due to gravitation it will be coming as mg. Okay, next the electric field due to point charge. Okay, electric field due to point charge na what was the equation we have mentioned? Kq divided by r square. And what I said when it comes to gravitation, instead of k we have the g value, instead of q we have m value, and distance of separation the same இருக்கும். புரிஞ்சுதாடா? So இங்க பாக்கும்போது kq by r square, அங்க பாக்கும்போது gm by r square. இதுக்கு தான் I have told you, you don't need to study anything new. K வரும்போது replace it as g, q வரும்போது you will replace it as mass. Okay, so next solid sphere இருக்கு, hollow sphere இருக்கு. கரெக்ட்டா? So அந்த solid sphere la in the what is electric field outside it will be coming as kq by r square, surface la kq by r square, inside kqr divided by r cube. So now straightly coming to here, so anga irukra kk, instead of that we will keep g, q we will replace it as m, then r square. Exactly for the same case we are just replacing the k and the charge. K and q will be replaced it as g and m. Purinjidada? Everybody understood? Yes or no? Is it going to be easy? Yes or no? Please let me know. So in the comparison making it lighter. Gravitation innum just a few minutes la we can finish. Okay, are you guys getting it? Marakama like pannikoda. Everybody like this video. Okay, so in the madri solid sphere la we have mentioned. Next the hollow sphere da, exactly the same thing. Idoda PDF class ku appuram comment box la you can find it. So hollow sphere la kuda wherever we kept k q, inga varumbodhu adu gm irukum. And also I have to be very specific when it comes to gravitation, adula additional or negative charge irukum. It is showing that, and the negative sign is indicating that idu always attractive in nature. Okay, in the gravitational force eppovume attractive in nature da. So adanala da constantly we are keeping the negative sign. Okay, ஆனா electrostatics la adula variation irukum. Ipo charges, depending upon the charges, it can be attractive, it can be repulsive, which means it can be negative as well as positive. புரிஞ்சுதாடா? So exactly whatever we have studied here, அதோட what to say, the gravitation ல இருக்கிற terms வந்து just we need to replace k and q. Okay, அங்க வரும்போது k னா இங்க வரும்போது g, அங்க வந்து m1 m2, இங்க வரும்போது q1 q2. That is the only thing. Okay, next வந்து circular ring da, அதோட value வந்து we understood. அப்படினா gravitation வந்து இந்த equation ஐ பார்த்து you can just predict what is going to be that. Instead of k it will be g, instead of q it will be m, instead of x it is same as x, r square plus x square all raised to 3 by 2. Now the gravitational potential, can you just let me know what is going to be the gravitational potential? Kq divided by r square plus x square all raised to 1 by 2. அப்படினா gravitational potential will be coming as gm divided by r square plus x square all to the power 1 by 2. Okay, so exactly the similar way potential energy irukku, potential energy kuda k q1 q2 divided by r, inga varumbodhu instead of k g m1 m2 divided by r. Potential for due to a point charge we know kq by r, inga varumbodhu gm divided by r. So in the first half of gravitation chapter vandu we have done. Okay, as I mentioned, we don't need to study anything. அந்த மாதிரி we don't need to put extra effort to study, nothing like that. We will just study electrostatics. அதிலிருந்து we are going to find the equation for the gravitation. இந்த மாதிரி we will be doing it for magnetism as well. Once you study electrostatics, magnetism chapter la vara we can say that half of the portion இந்த மாதிரி we can finish. Are you guys needed it? If you needed na, please let me know. Okay, இந்த magnetism chapter la கூட இந்த மாதிரி compare பண்ணி study பண்ணிட்டேனா நம்ம efforts வந்து இன்னும் half ஆ இருக்கும். Okay, we don't need to put much effort. So இப்போ வந்து உங்களுக்கு வேணும்னா இந்த கிளாஸ்க்கு அப்புறம் you should let me know in the comment box. Okay, so now apart from this we have few more things to study. In the class kapram I just wanted to know your valuable comments. Okay, so what are the things you needed and how was the class, what are the things we need to add in the class, everything I wanted to know in the comment box. Okay, yes I will do it. Okay, no worries. Okay, so ipo vanda gravitation chapter la we discuss some of the equations. Apart from that we should study few more equations. Okay, few more equations la first vara poradhu in the variation of acceleration due to gravity da. We know that in the acceleration due to gravity will vary with the depth, height, due to rotation, due to the shape. Correct? So இப்போ வந்து பாக்கும்போது we know in the g value will be coming as gm divided by r square. இந்த அந்த சாப்டர்ல எலக்ட்ரிக் ஃபீல்ட் மாதிரி இங்க வரும்போது we have the acceleration due to gravity. அந்த acceleration due to gravity will be gm by r square தான். And in the m க்கு வந்து we can substitute mass is nothing but density into volume. While we are substituting we will be getting this equation, or otherwise we know the gravitational force which is equal to mg. So this will be the another expression. So all possible equations I have written. So if it is changes with the height now, the equation will be coming as gm divided by r plus h the whole square. இப்போ வந்து இந்த height is actually less than 5% of the radius of earth. Okay, இதுதான் வந்து general expression. Okay, now we are going for the approximation. Note பண்ணிக்கோ, you should know it. gm divided by r plus h whole square is the general formula. If the height h is very small, okay, very small, which means it is less than 5% of the radius of the earth. 5% of the radius of earth. Now you can use this equation g into 1 minus 2h by r. Next one, if it is varying with the depth now, you can use this equation g into 1 minus d by r. D is the depth. Next one, the due to rotation in the acceleration due to gravity will also change. Adoda expression vanda g minus omega square r cos square lambda. Lambda na and the angle da which is making with the equatorial and the point where the object, or let's say point where we need to find the gravitation. Okay, another important relation which we already know, force is nothing but the negative gradient of potential. So that will be minus du by dr, and potential or a general expression we studied in the previous chapter. The work done divided by unit charge, negative sign will be there. Yena inge irukkiradhula we are just doing work done against the conservative force. Inga varumbodhu adu vandu gravitational force da, and which is also equal to potential energy per unit mass. Anga varumbodhu unit charge da, inga varumbodhu unit mass da. Okay, so in the part 1 we already discussed. Next one is the escape velocity. So ipo vandu or object is actually at the surface of earth, adukku vandu it needs to escape from the surface na, it should have a minimum velocity, adha vandu escape velocity, which will be coming as root 2 gm divided by r, which is also equal to root gr. Idoda value at the surface vandu 11.2 km per second da. Next vandu Kepler's laws. Kepler's laws la we were discussing about the first one. Every what to say, in the idellame vandu it is what is that, ellipse. Okay, so ellame vandu it is actually rotating in an elliptical orbit, correct? Next one, the area swept at equal interval of time will be equal, which means dA by dt will be coming as constant, which will be equal to L divided by 2m. L na angular momentum da, m vandu mass da. Next on the orbital velocity, we know that the satellites and everything is moving in an orbit. So if it is not on the specific orbit, it cannot move in a circular path. So adoda velocity vandu root gr illana root of gm by r da. Okay, so now we can say that this is you can just relate with the orbital velocity as well as the escape velocity as well. So idu da vandu important ana few relations that we should study from the chapter gravitation. So idhula vandu if you are just looking at the what to say, the kinetic energy of the what to say in the satellite oda motion la, kinetic energy, potential energy, total energy irukke. So adoda expression kuda important da. So I'll write it over here. Okay, so in the case la kinetic energy will be coming as gmm divided by 2r. Total energy will be minus of kinetic energy da, which means minus gmm by 2r, and the potential energy will be 2 times the total energy, which means g minus gmm divided by r it will come. So all the expressions were important. Everyone should study each and every expression. Is it done, everybody? All the equations, yena in the chapter la almost in the equations if you know na, almost all the questions easily you can do it. Okay, and 2 questions every year la, last 5 years la consistent it is asked for 2 questions. Okay, consistent they were asking 2 questions. So adanala I am telling you, in the at least in the equations podumda we can just get good score. Okay, so like paniko, share paniko, also subscribe the channel. Brain is overloading. Oh my god. Okay, we can't do anything. Okay, so in the time la brain ku vandu konjam overload irukkanum, illana NEET 2026 ku appuram we will cry. Okay, and the madri we are not supposed to happen. So adinala da இன்னும் கொஞ்சம் டேஸ் தானடா, ஹார்ட்லி வந்து 20-25 டேஸ் தான் இருக்கு. ஸோ அது வந்து மேக்ஸிமம் ஐ மீன் நல்லபடியாக இஃப் யூ ஆர் ஜஸ்ட் யூட்டிலைசிங்னா ஆஃப்டர் NEET 2026 நம்ம வந்து ஃபுல் ஆன் பவர், ஃபுல் ஆன் எனர்ஜியில் இருக்கும். ஓகே, ஸோ லெட் அஸ் டூ சம் கொஸ்டின்ஸ். ஆர் யூ கைஸ் ரெடி? Are you guys ready? Ready now? Give me a fire quickly. Give me a fire quickly if you are ready. Brain is not braining. I can understand, Arun, but let us just quickly go for some question solving. So definitely your brain will say, oh my god, I got something new. Okay, and over questions may solve pandra on the moment you will feel very happy also. Okay, so let us just try this. And as I mentioned, idukapram in the PDF வந்து available irukunda, adula many questions irukke. Over chapter la irundum I think I have added more than 60-70 questions irukke. So please do it. Question practice illama don't think like physics la score panna mudiyum and madri, you are not think about it. So please idu vanda as a request. Okay, full of formulas, ana vanda in the full of formulas la irundhu you can get good score. Adudha vanda nama key. Yes, we will study ma'am, fire adudha venumda. So now first question, particles of mass 2m, m, m are respectively at points A, B, C, with AB is equal to half of BC, much smaller than m is much smaller than m. At what time? At time t is equal to 0, they are all at rest. At subsequent times before any collision takes place, what will happen? What will happen? So think about the forces acting. Okay, so which force will be higher, which towards which direction it will move? Marakama like paniko everybody, marakama like paniko. Also share with your friends da, let us make it more competitive. So in the case m will remain at rest after some time, or m will move towards small m or towards 2m, or he will have oscillatory motion. Idudha vanda, yes, I can say lots of fire and what to say, crackers also there. So let us do it quickly. Give me the answer quickly. Podunda fire podunda, do this question everybody. I want the answer. No, Arun, your brain will definitely brain. பரவாயில்லடா, உன்னால முடியும். உங்க friends நீ படிக்கலையா, பரவாயில்லடா, you are enough. So இப்போ வந்து பார்க்கும்போது இந்த diagramல you can see that this m will experience a force due to 2m. இது வந்து as I mentioned எப்பவுமே attractive-ஆ இருக்கும். So in the 2m will also attract, this m will also attract. So the thing is like in the question you should understand or you should tell me the force exerted by in the 2m force exerted by 2m and the force exerted by m irukku. Okay, so and the small m in the 2m will also exert some force and the capital and the m will also exert a force on small m. எப்படினா in the case which one will be larger, which force due to 2m or m, which one will be larger, which is experienced on m, which is going to be larger? Very good Durai Singha. Okay, very good. So what will happen when I'm looking at the force due to this 2m? The force will be coming as what? G into 2m into m divided by the distance. If I am taking this as x, I am writing x square. Now due to this capital M, I can say G into mm divided by, idu vanta x na, according to the question this will be 2x. So 2x the whole square. So now tell me now which force will be more? Very good. The force exerted by 2m will be more. Appadina this m will move towards 2m. So I can say option C is going to be the right answer. Now 3 masses each containing mass capital M at the 3 corners of a square. Okay, so ipo vanda we have a square, adoda side vanda A da, so 3 masses irukke, capital M da. Okay, and the force of attraction on unit mass at the 4th corner. Inge, if I am just placing a unit mass m naught, what is going to be the net force experienced by it? Again superposition principle. Okay, so what we will do, we will be just going to check the direction of force. So definitely the vanda ellame vanda attractive in nature da, yena mass cannot be negative, idu vanda scalar always vanda positive ah irukum. So definitely this, I mean towards this M there will be attraction, towards this M there will be an attraction, towards this M diagonally there will be an attraction. And you need to find the sum of it. You can see that the force exerted by this M, force exerted by this M will be same. Only the thing is like the force which is due to this capital M will be different. And on the distance of separation it is different. Okay. Now it is your turn. Can you find it? Can you find the answer for me quickly? Can you find the answer for me quickly? Everybody, quick, you can give me the answer. First you should understand what is F. Okay. So F will be coming as GMM divided by A square. Okay. And this one is F. This one is also F. Now F dash will be GMM divided by, what is this distance? This is A, this is also A. So we will be getting 2A square. Okay. Now you have to find the sum of it. Quicker you can give me the answer. Quickly you can give me the answer. Yes, I am getting the right answers. Very good, very good, very good. Harini, right? Yes. So and the two forces, in the two forces one the perpendicular da. So adoda resultant one the root to F arkum. Okay. And that is along the same direction of F dash. So root 2 into F na GMM divided by A square plus GMM divided by 2A square. Okay, very good, very good. I can see the right answers. So we can say option D is going to be the right answer. Just we need to take the GMM by R outside. Okay. So next one, if the radius of earth shrinks by 2%, which means and the radius one the reduce at 2%, mass remaining constant, then how would the value of acceleration due to gravity changes? So acceleration due to gravity or expression one the Gm divided by R square. We need to find the percentage error in the or percentage change in the G value. So I can go for delta G by G into 100, which will be in the Gm na constant adula the change kadayadu, and here I will be getting minus 2 delta R by R into 100. Okay. So now the thing is like you can just put this value delta R by R into 100, which is already given in the question, and you can just substitute. Attendance mark they will just come, they will enjoy the session, they will do all the questions, and they will get to know the concepts clearly, and they won't appreciate. And I have few people who is always there for me, and I need that. That is why I am also not asking for the likes and all. Let it be. They just sit like this. But I have my students, and they are ready to give a lots of heart whenever I was asking, whenever my energy is getting low. Even without asking, these people were giving a lots of heart, and that is what I need. So thank you so much. Yes, Da, we are here. I know it. Yes. So, we are just using the percentage error equation. Percentage error equation we will be getting delta G by G into 100. This is nama error chapter I have copied this equation. Okay. So, minus 2 into delta R by R into 100. We are army of Lerin, ma'am. Thank you, Da. Thank you so much. Okay. So, idhula vandu paakumbodhu minus 2 into what is delta R by R into 100, that is also coming as minus 2, that is reducing, correct? So, we will be getting 4%. So, this is actually a positive number, which means the acceleration due to gravity will increases by 4%. Understood? Understood everybody? Everybody understood, yes or no? So next one is how much below the surface of earth does the acceleration due to gravity become? 1% of its value at the earth surface. Radius of the earth is 6400 kilometer. Okay, innum 10 minutes la we need to finish. 10 minutes da irukke. So அந்த டைம்ல possible இருக்கிற questions வந்து we can just do it. ஆமாடா percentage change தானா they have asked, so you can just use this. Done everybody. Okay, so now here what is the question? Acceleration due to gravity, it is become 1% of it. Okay, acceleration due to gravity become 1% of it, which will be equal to what must be the, what is a depth they have asked, right? How much surface does acceleration due to gravity? 1% of value of the earth, the surface radius of the earth is 6400 kilometers. Yeah, definitely we should find what is the distance from the center to get the acceleration due to gravity as 1%. Okay, so adukkaga we can just go for one thing. So inga varumbodhu inda g dash na adoda meaning enada g by 100, which means 1%. Okay, which will be equal to g into 1 minus d by r. So inga irundhu paakumbodhu we should find this d value. So 1 by 100, which is equal to 1 minus d by r. So if I am taking this d by r over there, okay, I will be getting 1 minus 1 by 100, which is nothing but 99 by 100. So d will be coming as 99 by 100 into r. Now it is your turn. You can just do the calculation. Quickly give me the answer. Quickly give me the answer, everybody. Yes, I am getting the right answers in the chat box. Very good, very good, very good. So option D it will come. Yes, 6336 it will come. Starting from the center of the earth having radius r, the variation of g is shown by. So it is exactly the same graph of what to say our solid sphere, electric field la irukra and the same graph inge kuda you can just copy it. Yena earth na adukulla mass irukku, so you can just consider it as a solid sphere. So on the solid sphere la what is happening in the electrostatics, same thing you can use it here. So what is happening? Solid sphere la from 0 to the surface, from the center to the surface, it is actually proportional to the x. Okay, it is actually proportional to x. Just compare the equations we have compared. No, same thing you can use. So idhula vandu paakumbodhu g will be proportional to x till the r value become capital R. Adukapram we know that this will be proportional to 1 by r square. Appadina which graph is representing the right answer? Yes, Sasmita, right? Very good. So it will be coming as option D as the answer. Option D. Very good, very good, very good. Okay. So marakama subscribe panniko. As I mentioned, we have many different sort of classes are coming for you people. So wait and see. If earth has a mass 9 times and radius twice that of a planet of Mars, okay, so mass vanta 9 times adhigama irukku, radius vanta 2 times adhigama irukku. Okay, calculate the minimum velocity required by a rocket to pull out of the gravitational force of Mars. Take the escape velocity of the surface earth be 11.2 kilometer per second. Okay, again easy question. So in the escape velocity oda expression vandu we know. Okay, escape velocity is nothing but root of 2gm divided by r the expression. Lena, you can just go for root of 2gr. Correct? So now what happened? Idu vanta escape velocity from the earth surface. Idoda value kuda it is given 11.2 kilometer per second. Next vanta in the Mars il irukra escape velocity da we need to find. So adala vantu we can see that 2 into g mass vantu 9 times adhigama irukke divided by radius is twice, which means 2r. So appadina you can just replace this. Here what will happen, I am just writing root 2 gm divided by r. What else we have here? Root of 9 divided by 2. Okay, 9 divided by 2. So idoda value vandu we know 11.2 da into root of 9 by 2 da we need it. Root 9 na 3 da, root 2 oda value vandu it is already given in the question. You can substitute and you can find the answer. Everybody quickly give me the answer da. Quickly give me the answer. I hope the method is okay. Quickly. Yes. The answer was the option C, the 5.2 kilometer per second. Let us quickly go for the another question. Okay, so suppose a vertical tunnel is along the diameter of Earth. Okay, this is the vertical tunnel. And now the Earth is assumed to be a sphere of uniform mass density rho. If a body of mass m is thrown in the tunnel, its acceleration at a distance y from the center is given as. Y from the center is given as. How we will be finding it? So in the case of acceleration, the acceleration due to gravity. So exactly similar to the solid sphere or electric field inside. Okay, solid sphere or gravitational field inside. Adoda expression enna? Gravitational field or expression enna? Ig, which is equal to gmx divided by rq. Illada, idha vandu we have studied in the comparison la we have mentioned no electrostatics la kqx divided by r cube na inga varumbodhu gmx divided by r cube. Appadina in the case la x oda value varaporadhu y da divided by r cube. So ipo vandu paakumbodhu the answer is given in terms of density. So mass vandu we need to change, correct? So mass na density into volume da. So density into volume is nothing but 4 by 3 pi into r cube da. Now I am going to substitute here g into rho 4 pi r cube into y divided by 3 r cube. So what will happen? R cube will be get cancelled, and finally we will be getting g rho 4 by 3 into y. So is this option is there in the 4 by 3, 4 pi. Okay, pi will also be there. Okay, 4 pi, yes, we will be getting the option A as the answer. Understood everybody? Yes or no? Everyone is getting it? Are you guys getting it? Yes or no? Please let me know quickly. Okay, so now actually I have made a lot of questions here, but as I mentioned, all the question detail solutions I have added. So now the thing is like you guys can practice the questions. Okay, idukappuram innum 10-15 minutes la in the PDF you will be getting it. Don't worry about it everybody. But as I mentioned, questions practice pannanum. Adukku excuse kedaiyadu. Everyone should practice all the questions. Next class tomorrow 4 o'clock. Adu we will extend. Yena studio ellame I have booked it, so no worries on it. So next class 4 o'clock gida. Everyone should join the class. As I mentioned, current electricity irukum, semiconductors irukum. Till 10 o'clock we will continue. We will take proper breaks as well. In the session kappuram I want the feedback from all you people. Okay, I wanted to know how was the class and what you guys needed after this chapters, what you guys needed. Ungaloda targeted score enna, adukku what are the things you needed. Idellame I wanted to know in the comment box just after the session. I will check everyone's comment and I will give the reply as well. Any concerns irundichna please let me know, comment box la we can talk. Okay, so that is what I wanted to tell you. So next class la meet pannalam da, everyone should join on time. Okay, 4 pm ku da session time. I hope everyone will join on time. Yes or no? Ipo vanda if you are coming on time na, give me a fire quickly. If you will come at 4 sharp 4, I will check all the names tomorrow. Okay, tomorrow in the session start பண்ணும்போது I will check all your names. So everyone will come, right? No, you people won't come. Yes. So in the names ellame vanda I am noting it down. Okay, so நாளைக்கு வந்து first வந்து I will be asking all your names. Yes. So let us just rock the tomorrow session. I hope everyone will come. So thank you so much guys. இன்னைக்கு வந்து session timing வந்து கொஞ்சம் லெஸ்ஸா இருக்கு, பட் பரவாயில்லடா, நாளைக்கு வந்து காம்பன்சேட் பண்ணலாம். And questions வந்து practice பண்ணிக்கோ. Feedback மறக்காம you should give me in the comment box. Thank you so much da. Thank you so much for the care and love. Bye, good night.